In terms of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice for your entrance exam question papers, maybe this one or a variety of other entrance exam question papers, similar type of. You must download our app. The link is available in the description box for a very comfortable and smooth journey towards your preparation. Students, today we'll be solving EAMCET 12th May 2023, Shift 2 paper. You know, this paper is having different sections like physics, chemistry, and mathematics. We'll be dealing with the mathematical part of the paper in this video. Let's go with the question number 1. Here we go. The question number 1 says, first of all, a very best of luck. It is the domain of the function fx is equal to sine inverse log 2x square by 2 is equal to what? See, to find the domain of fx, you need to find out the domain of this. So basically, I need the domain of this, right? Where log 2x square by 2 belongs to -1 and 1. That means -1, this log 2x squared by 2, it lies between the range of -1 and 1, which means -1 by 2 is less than equal to x squared by 2 is less than equal to 2. Or 1, not sorry, minus, this is 1, 1 by 2. 1 is x squared lies between 1 and 4. For x squared to be less than equal to 4, x will lie in this range. That means it will belong in this range. Also, x square is greater than 1. So that means x belongs to open minus infinity minus 1 union 1 infinity. Now let's say this is equation 1 and this one is 2. So from 1 and 2, I'm taking the intersection. What we get is x belongs to -2 to 1, -1 union 1 and 2. So this is the answer to the question. Let's check. You have option C. This is the answer. Hope you understood that. Next is question number 2. The range of the function fx is equal to this is equal to what? Okay, you're given this function. Let's write it like minus of, I'm taking minus common from here, x square plus 6x plus 5, right? Let's say this is equal to y. This was equal to fx. Let's say this is equal to y is equal to fx minus of x square plus 6x plus 5. Let's find out its factors. So minus of, I'm factorizing it over here, x square plus 6x plus 5. For sure, the two factors are 5x and x. Okay, I'm taking x common, x plus 5 plus x. So the two factors, x plus 1, x plus 5. Okay, now squaring on both sides. That is equal to y. Squaring both sides, you have y square is equal to minus of, let's write this only for the time being. So you will have y square is equal to minus x square minus 6x minus 5, or you have x square plus y square plus this plus 5 is equal to 0, or x square plus 6x plus 5 plus y square is equal to 0. This is equal to 0. Now I'm applying the quadratic formula to find out the roots. So x will be equal to, you know the formula, this is minus b plus minus b square minus 4ac upon 2a. So x is equal to minus 6 plus minus 6b square, which is equal to 36 minus 4 into 5 plus y square. This whole is being divided by 2. So this is minus y plus minus root of 16 minus 4y square upon 2. Now clearly, this is positive, which means y square is less than 4. So y square is less than equal to 4, which means y lies between minus 2 and 2. So clearly, y is negative because this is positive, which means so y belongs to y belongs to minus 2 to 0. Thus, the range of the given function is this. So this is the answer. Let's check. You have a B option. This is your answer. Hope you got this. Next question number 3. If f is a function from real to real numbers defined by this, where x belongs to the real number, then what is f? You are given fx is equal to 2x plus sin x, where x belongs to the real number. For 1 function, f of x1 is equal to f of x2, which means 2x1 plus sin x1 is equal to 2x2 plus sin x2. This is possible only when x1 is equal to x2. So fx is 1, 1. For onto range of this function, so range is equal to codomain, or fx is onto function. Okay, that means let's check with the options. You have 1, 1 and onto, option A for sure. Hope you got that. Next is question number 4. So now you have a matrix problem before us. Let's write down. You have to find a determinant. So it's quite simple actually. But before solving this, I can see some things which can be taken out common, which will really help us in diminishing our calculations. Okay, so I'm starting from here, taking root 3, root 5, and root 5 on C1, C2, and C3. We get root 3 into root 5 into root 5. So I'm taking root 3 common from here. This will be 1 root 5 root 3. This will be 2 root 5 root 3, 1 root 2, and root 5. So that's equal to 5 root 3. Now, let's apply some operations. This will make it even easier. Wait, let's write down. Let's apply C1 to C2 minus C1. Okay, because I'm having this 2, right? So that's right. So then this matrix will become 5 root 3, 1, 1, 1, root 5, root 3, 0, 0, root 2, and root 5. Okay. So 5 root 3, I'm extending from this one. Okay. This will be 5 into 5, 1 into, actually minus 1, because this is minus 1. This is in the first row, second column. So minus 1 raised to power minus 1. Let's write it here itself. Minus 1 raised to power 1 plus 2. Root 5 into root 5. This is equal to 5. Root 3 into root 2. This is root 6. Okay. Yeah. So now let's see. This is minus 5 root 3 into 5 minus root 6. So let's open it. This is minus 25 root 3 plus 15 root 2. Or you can say 15 root 2 minus 25 root 3. This is the answer to the question. And we have option D as the answer. Hope you got that. Next is question number 5. If A is a non-singular matrix, then A minus 2i into A minus 3i is equal to 0. Then what is the value for this expression? See, you are given A is non-singular matrix such that this is equal to 0. Okay, see, it's a non-singular matrix. That means a determinant exists. Determinant, sorry, is not equal to 0, which means its inverse exists. So let's come back to this one. You have this as a squared minus 2a minus 3a plus 6i is equal to 0. A squared minus a 6i is equal to 0. Multiplying both sides by a inverse. Multiplying both sides by a inverse, you have 5 minus I plus 6a inverse is equal to a inverse into 0, which is equal to 0. So that means a upon 5, I'm dividing both sides by 5 now, plus 6 upon 5 a inverse minus 5 minus identity is equal to 0, or a upon 5 plus 6 upon 5 a inverse is equal to identity. So that means this is equal to option B. Hope you understood that. Next, question number 6. If A is AB a matrix such that AB is a scalar matrix where B is equal to this and determinant of 3A is equal to 27, then what is the value for 3A inverse plus A square? So you are given that AB is scalar matrix. So let's say this is equal to this, right? Yeah, it's a scalar matrix. So let's say this is equal to this, where lambda is your scalar, and you are already given that B is 1, 2, 0, 3. Also, you are given the determinant of 3. Wait, it was determinant 3A is equal to 27, or simply you will say determinant of A is equal to 27 upon 3, which is equal to 9. And from here, from let's say A, B, C, D. And we already took like AB is equal to lambda 0, lambda 0, 0, lambda. Then further, you have to find out, let's go for AB. This will be A, B, C, and D. And B is 1, 2, 0, and 3. This is equal to this. So you have this as a first row, first column. So A, 2A plus 3B. Then you have C, 2C plus 3D is equal to this. Now comparing on both the sides, I have a is equal to lambda and 2a plus 3b is equal to 0. C is equal to 0 and 2c plus 3d is equal to lambda. So from here, I have see a is equal to lambda. So this will give me b 2 lambda plus 3b is equal to 0, which gives me b is equal to minus 2 upon 3 lambda. And from here, I have c is equal to 0, which gives me d is equal to lambda upon 3. So simply, I got my A matrix as which was A, B, C, D. This comes out to be lambda minus 2 pi upon 3, 0, and lambda upon 3. Let's find out the determinant of this now. So A determinant will be equal to lambda square upon 3. Yeah, and minus 0. That was equal to 3. No, sorry. What we calculated was 9. Determinant was equal to 9. So this gives me lambda square is equal to 9 into 3, which gives me lambda is equal to 3 root 3. Right? Mm, Question number 6, let A be a matrix such that AB is a scalar matrix where B is given as this one and determinant of A is 27. Then you have to find out the value for this particular expression. Okay, first of all, you are given that AB is a scalar matrix. So let's say AB is this. Thus it's given it's a scalar matrix. So let's say AB is equal to this matrix. Also, you are given one more thing here. The lambda is a scalar. Also, you are given that let's suppose A to be A, B, C, and D, and B matrix it's already given 1, 2, 0, 3. You are given AB is equal to this. Okay, let's go AB. Let's find the product of these two matrices A, B, C, and D. Then 1, 2, 0, and 3. So here you have A, and here you have 2A plus 3B. Then you have C, then 2C plus 3D. Now you are given, we assume that this is equal to this. So let's compare. You have A is equal to lambda, C is equal to 0. 2A plus 3B is equal to 0, which gives you 2 lambda plus 3B is equal to 0, or B is equal to minus 2 by 3 lambda. Also, 2C plus 3D is equal to 0. C was 0. Sorry, this is equal to lambda. So you have D is equal to lambda by 3. So simply you have the A matrix, which was A, B, C, and D. Now what does this matrix become? A is equal to lambda minus 2 pi by 3. C was 0, and this is equal to pi by 3. Now let's find out the determinant of A, which is equal to pi square upon 3 plus 0. And we were also given one more thing. Determinant of 3A is equal to 27. Right? Yeah. So, see, if determinant of 3A is equal to 27, then and this means determinant of A will be equal to, because this is a second order matrix. Okay, this can be written like this. Correct? So determinant of A will be equal to 3. Correct? So that means this is equal to 3. You have pi square upon 3 is equal to 3, which gives you the value of pi as sorry, not pi, it's lambda, which gives you the value of lambda as plus minus 3. So now what we had to get to the question was this 3a inverse plus a square. So first of all, let's find out a square. A is equal to, we got the value for lambda. Let's fill in lambda. It was, wait. It was lambda minus 2 pi by 3. Lambda minus 2 lambda pi by 3, 0 lambda by 3. Right, I have to find a square, so let's multiply this. 0 and pi by 3. So this is equal to lambda square, first to first column, 0, I'm not writing that, minus 2 lambda square upon 3 minus 2 lambda upon 9, lambda square upon 9. Here is 0, here is lambda square upon 9. So this can be written as lambda square minus 8 lambda square upon 9, 0 lambda square upon 9. Okay, we already know that lambda square is equal to 9. See from here, lambda square is equal to 9. So let's fill. So this becomes 9 minus 8, 0 and 1. This is your A square matrix. Now clearly A inverse is equal to, A was, let's write it again. It was lambda minus 2 lambda by 3, 0 lambda by 3. So A inverse, I'm taking the positive value for the lambda. This can be 3 and here will be minus 2. Yeah, and 0 and 1. Okay, so right, 2 upon 3. Okay, yeah. This is A matrix, right? I have written the A matrix. I've put the values of lambda. So this is A matrix. Now what will be A inverse? First of all, 1 upon the determinant. And then I will switch these two positions. 1 will come over here, 3 will come over here, and the signs will be changed in this case. So this is the A inverse matrix. Correct. Now 3 A inverse is equal to 1, 2, 0, and 3. Now 3A inverse plus A square is equal to 1, 2, 0, 3 plus 9 minus 8, 0 and 1. So this is it. This is equal to 0, minus 6, 0 and 4. So this is the answer to the question. Let's check. You have a option. Which of these is the correct answer? D. So option D is the correct answer to the question. Hope you got that. Next question number 7. If A is a symmetric matrix with real entries, then A inverse is symmetric. If it exists, A inverse always exists and symmetric. A inverse is skew symmetric if it exists, and A inverse always exists and is skew symmetric. Fine. So see, if A is symmetric matrix with the real entries, then A transpose is equal to A. Now suppose A inverse exists. So A inverse transpose is equal to A transpose inverse is equal to A inverse. Thus, A inverse is symmetric. That means A inverse is symmetric if it exists, right? Option A is the correct answer. Next is question number 8. Argument of this complex number, which is involving trigonometry as well, is, let's say this is equal to Z, not this. Let's say this Z is the complex number sine 6 pi by 5 iota 1 plus cos 6 pi by 5. Therefore, clearly sine 6 pi by 5 and 1 plus this, they lie in the second quadrant of complex plane. Hence, its argument is pi minus tan inverse y upon z, because z is equal to x plus iota y for all x less than 0 and y greater than 0. So, pi minus tan inverse 1 plus cos 6 pi by 5 whole divided by sine 6 pi by 5, that's pi minus tangent inverse 1 minus, this can be written like this because this is 5 pi plus pi by 5, and similarly here I can write it as sine pi by 5 as well. This is the mod. Okay, actually this is not the brackets, this is the mod. So 1 plus cos pi by 5 is pi minus tan inverse 2 sine square pi by 10 upon 2 sine pi by 10 cos by 10. So these will cancel and you have pi minus tangent inverse tangent of pi by 10, which is pi minus pi by 10 or 9 pi by 10. So this is the argument of the given complex number. 9 pi by 10. Option D is the correct answer. Hope you understood that. Next is question number 9. If x plus iota y is equal to this, then what is the value of x square plus y square whole square? So let's write down the complex number. X plus iota y is equal to 3 plus iota upon 1 plus 3 iota. Its conjugate will be this upon this. So x minus iota y will be 3 minus iota upon 1 minus 3 iota. Let's say this is 1 and 2, multiplying 1 and 2. You have x plus iota y, x minus iota y is equal to root 3 plus iota upon 1 plus 3 iota into 3 minus iota upon 1 minus 3 iota. This is equal to x square plus y square, and this is a square, which is 9 minus of iota square. You know, it was iota square is equal to this, and minus of iota square will be equal to minus of minus 1, which will be equal to 1. Okay, so this is 9 plus 1 upon 1 plus 3 iota, 1 minus 3 iota square. So this is equal to 10 upon 1. This is minus, so this will be like this, 1. So x squared plus y squared is equal to 1, and you have to find out the square of it, which is equal to 1 again. So this is the answer to the question. Shit! क्या हुआ? मैं 9 क्वेश्चंस रिकॉर्ड कर ले माइक थल्ले सीगा. देखो आवाज आ रही थोड़ी बहुत या नहीं? Question number 9. If x plus iota y is equal to root of 3 plus iota upon 1 plus 3 iota, then what is the value of x squared plus y squared whole square? Let's see if I say the conjugate of it, this is given by 3 plus iota upon 1 plus 3 iota whole under the root. So x minus iota y is equal to 3 minus iota upon 1 minus 3 iota. Let's say this is equal to 1 and this is number 2. So multiplying 1 and 2. You have a x plus iota y into x minus iota y is equal to root of 3 plus iota upon 1 plus 3 iota into 3 minus iota upon 1 minus 3 iota. So you have x square plus y square is equal to root of a minus b square upon a square minus b square whole under the root. This is equal to 3 plus 1 upon 1 plus, 3 not, it's 9. 9 plus 1 upon 1 plus 9, or x square plus y square is equal to root of 10 upon 10, which is equal to 1. And you have to find the square of it, which will be equal to the 1 square, or this will be equal to 1 only. So that means you have option B as your answer. Hope you understood that. Next is question number 10. If the imaginary part of this is equal to minus 2, then the locus of the point representing z in the argent plane is what? Okay. So you have, this is 2z plus 1 upon iota z sin z plus 1. Let's say z is equal to x plus iota y. So 2z plus 1 upon iota z plus 1. Let's say z is equal to x plus iota y, the complex number. So 2 into x plus iota y plus 1 upon iota into x plus iota y plus 1. This is equal to 2x plus 1 plus iota 2y upon iota x minus y plus 1. So this is 2x plus 1 plus iota 2y upon 1 minus y plus iota into x. Let's rationalize the denominator. So you will have 2x plus 1 iota 2y whole divided by 1 minus y plus iota x. This is 1 minus y minus iota x in the numerator also. 1 minus y minus iota x. So this numerator will be equal to now 2x plus 1 into this plus iota 2y minus y square minus iota 2x square plus x plus 2xy. The whole denominator will be equal to a square plus b square, which is this. Okay. So now you are given in the question that the imaginary part is equal to minus 2. Look over here. So that means, according to the question, you have 2y minus 2y square minus 2x square minus x upon 1 square plus y square minus 2y plus x square is equal to minus 2. Or you have 2y minus 2y square minus 2x square minus x is equal to minus 2 minus 2y square plus 4y minus 2x square. 2y minus x plus 2 minus 4y is equal to 0. X plus 2y minus 2 is equal to 0, which is a straight line. All right. So that means you have option B as your answer. Hope you got that. Next is question number 11. If omega is not equal to 1 is a cube root of unity, then what is the determinant of this given matrix? Okay, so let's split it up first of all. This is quite a big matrix. Let's split it up. You can write it as omega square, omega raised to power 9, omega 27, 31, 17, 30, 41, and 19 plus omega square, omega 9, omega 31, 41, 17, 19, 27, and 30. Now, I'll take omega common from here, and omega 17 from the first row I'm taking omega common, from the second row I'm taking omega raised to power 17 common, and from the third row I'm taking omega raised to power 19 common. So this whole will now be 1 omega raised to power 8, omega raised to power 10, 14, 1 omega raised to power 11, 22, and 1. Plus, so now I'm taking from this one, I'm taking omega common, omega raised to power 17 common, omega raised to power 19 common again. So this will be omega into omega 17, omega 19. So this will be omega 8, 1, omega 14, 1, and omega raised to power 10, omega raised to power 22, 1, and 11. So here you have omega raised to power 37, omega. See, omega raised to power 8 is nothing but omega raised to power 6 square, and omega raised to power 6 is equal to 1. And this can be written as omega. This can be written as omega square, 1, omega square, omega, and 1, plus omega raised to power 37, omega square, 1, omega square, 1, omega, 1, omega square. See, you know one thing, I think that omega cube is equal to 1. So I have used that thing only everywhere. All right. Okay, so now see, this row, these rows and columns, if you will find out a determinant of them, 1 omega square, 1 omega square, and all that. So this will be, determinant will be equal to 0. Let's see how we got to it. Omega cube, let's find out the determinant. This will be equal to 1 into omega square plus omega minus omega into omega minus omega square plus omega square minus omega raised to power 4. Here is minus, not the plus. Okay. And similarly, plus omega 37, this will be omega into omega square minus omega square, omega raised to power 4 minus omega square, 1 omega square minus omega. So this will be omega square minus omega square plus omega cube, which is equal to 1, plus 1, because omega square into this omega raised to power 4, that's equal to omega only, and omega raised to power 6, this is equal to minus 1. So this will cancel, and this will cancel, and this will cancel, plus omega raised to power 31. You have omega cube, which is equal to 1, minus omega square minus omega raised to power 6, which is again 1, plus omega plus omega square minus omega. So this will cancel, this will cancel, and this will cancel. So you have omega raised to power 37 into 0, omega raised to power 37 into 0, which is equal to 0. So the answer to the given question is equal to 0, option D. Hope you got that. Next is question number 12. If iota is equal to root of -1 and 1 plus iota raised to power 10 plus 1 minus iota raised to power 10 is equal to. Okay, so 1 plus iota raised to power 10, 1 minus iota raised to power 10. This can be written as 1 plus iota square raised to power 5 and 1 minus iota square raised to power 5, which is equal to 2 iota raised to power 5 plus minus 2 iota raised to power 5. We got this like 1 plus iota square is equal to a square plus b square plus 2ab, which is equal to 1 minus 1 plus 2 iota. Similarly, this is for 1 minus iota, you have minus 2 iota over here. So this is equal to 32 iota minus 30 iota raised to power 5 into the iota minus 32 iota raised to power 5. 32 I'm taking common, iota raised to power, iota raised to power 4 is equal to 1. So this is iota minus iota, that is equal to 0. So you have option C as your answer. Hope you got that. Let's move to the next question. Question number 30. The set of all values of x which satisfies both the inequations, this and this, simultaneously is which of these options? So you are given the two inequalities as first one is x square minus 1 is less than equal to 0. And the second one is x square minus x minus 2 is less than, it's greater than equal to 0. All right. So now this can be written as x square is less than equal to 1. That means x is lying between -1 and 1. So if I consider the second one, let's factorize it. So the two factors will be minus 2x plus x minus 2 greater than equal to 0. So the two factors from here will be x minus 2 and x plus 1. So that means from here the x belongs to minus infinity and 1 union 2 and infinity. So does this factor of all values of x for which is satisfying both of these equations, set of all values of x satisfying both inequalities is only -1 is there. All right. So you have option D as your answer. Hope you understood this. Next is question number 14. For all the real values of x, the minimum value of this expression is. So you are given, let's say this is fx, you are given the equation, the function as 1 minus x plus x squared whole divided by 1 plus x squared. Now differentiating on both the sides with respect to x. Differentiating both sides with respect to x. With respect to x, you have a okay, this is going to be lengthy one. So f dash x, this is equal to, first of all I will write down the denominator square, 1 plus x square whole square, then denominator will be written over here, and then the derivative of the numerator. So this is -1 plus 2x minus then you have the numerator 1 minus x plus x square and 1 plus a derivative of the denominator, so 1 plus 2x. Now let's open it. You will get it as this will be -1 plus 2x minus x plus 2x square minus x square plus 2x cube. Now minus, here will be 1 plus 2x minus 2x square plus x square plus 2x cube. When you will open up, this will be minus, so this and this will cancel. And what more things will cancel? This and this will cancel. This will cancel with this as well. And yeah, so let whole divided by 1 plus x square whole square. So that means that now it will be reduced to that will be plus x square. This will be x square minus 1 plus x square whole divided by this. Okay, so this will be 2x square minus 2 whole divided by 1 plus x square. Now, for the real values of x, the minimum value, for the minimum or the maximum, the derivative should be equal to 0. So that means f dash x should be equal to 0, which gives you 2x square. I'm taking 2 common from here. So this is x square minus 1 plus x square. So whole divided by 1 plus x square should be equal to 0. This gives you 2x square minus 1 should be equal to 0, or x square should be equal to 1. That means x is nothing but plus minus 1. Hope you understood till here. Now, you can have two values of x. For x is equal to 1, f of 1 will be equal to, this was 1 minus x plus x square. Wait, let's write down f x 1 minus x plus x square whole divided by 1 plus x square. So f of 1 is equal to 1 minus 1 plus 1 upon 1 plus 1 plus 1, which is equal to 1 by 3. And for x is equal to minus 1, f of minus 1 will be equal to 1 plus 1 plus 1 whole divided by 1 minus 1 plus 1, which is equal to, yeah, that's equal to 3. So the minimum value of fx, minimum value of fx is 1 by 3 for sure. That means you have option B as your answer. Hope you understood that. Let's move to the next question, number 15 now. The quadratic equations, this and this, have one root in column if the other roots of the first and second equations are integers and are in the ratio 4:3, then their common root is. So you are given the two equations. First one is x square minus 6x plus a is equal to 0. Then you have x square minus cx plus 6 is equal to 0. Now they have told you they have one root in common. So let's say alpha is a common root. Is a common root for both the equations. Thus, other roots of the first and the second equations will be, see, if alpha is common root for both the equations, then what will be the other roots? Thus, other root, you are given the other roots of the first and second equation are integers and they are in the ratio 4:3. Then the other roots will be 4 beta, let's see, 4 beta and 3 beta. So, hence, alpha and 4 beta and alpha and 3 beta are the roots of first and second equation respectively. So from here, see, you know, the sum of the roots is given by minus b over a, which is minus the coefficient of x upon the coefficient of x square, and the product of the roots is given by c upon a. All right, so here it is, sum of the roots is equal to minus of minus 6 upon 1, that is equal to this. That means alpha plus 4 beta is equal to this. Also the product of the roots, that is 4 alpha beta is equal to c upon a. C is the constant thing, which is a in this case. So that's a. And for the second equation, this was for the first equation. For the second equation, the sum of the roots is equal to C, and the product of the roots is equal to 6. Okay, so from here you have alpha into beta is equal to a by 4. So I'm filling it in this over here. A by 4 is equal to 6, which gives you a is equal to 6 into 4 upon 3, that is equal to 8. I got the value for 8. So now let's say equation 1 becomes, it was x squared minus 6x plus a is equal to 0. So this equation is x squared minus 6x plus 8 is equal to 0. So let's split the middle term. You have here minus 4x minus 2x plus 8 is equal to 0. So the two factors will be x minus 4, x minus 2 is equal to 0. So that means x can have the value as 2 and 4. Okay. So if I take, like, see, one of the roots is common. Let's say x is equal to 2 is a common root. Then the second equation was given to you as x squared minus cx plus 6 is equal to 0. Then the second equation will be x squared minus c into 2 plus 6 is equal to 0. Sorry, x was taken as 2. So 4 minus 2c plus c is equal to 0, which gives you 10. That means c will be evaluated as 5. Okay. So therefore, the second equation will be x squared minus 5x plus 6 is equal to 0. This is your second equation. Again, let's split the middle term. So x squared minus 6x plus x plus 6 is equal to 0. So you have the two factors again. Okay. Wait. 3, 2. I'll take the two factors as this one. X squared minus 3x. Yeah, because see, minus 6 and 1, I'll be multiplying, I'll be getting minus 6. Okay, so this is not possible. This will be the two, I'm splitting the middle term. So it will be x squared minus 3x minus 2x plus 6 is equal to 0. So the two factors will come out to be x minus 3 and x minus 2 is equal to 0, which gives you x. The possible values of x are 2 and 3. So see, I got my answer. X is equal to 4 and 2. These are the roots for the first equation, and x is equal to 2 and 3. These are the roots for the second equation. Therefore, common root in both the equations is equal to, in common root in both equations is x is equal to 2. Okay, let's check. You have option C. This is your answer. Hope you understood this. Next, question number 16. If alpha and beta are the roots of this equation, then what is the value of alpha raised to power 15 plus beta raised to power 15? Let's write down the equation is x squared plus 2x plus 2 is equal to 0, which is written as x plus 1 whole square. Plus 1 is some extra. So this will be x plus 1 whole square is equal to minus 1. So see, that's actually not possible. Here I can write down x plus 1 is nothing but root of minus 1, that is iota, plus minus iota actually. Correct? Now, let's, x can be written as iota minus 1, or x is equal to minus iota minus 1. Let's say alpha is equal to iota minus 1 and beta is equal to minus iota minus 1. So alpha square is equal to minus beta square into beta square, which is minus 2 iota, right? So alpha raised to power 15 plus beta raised to power 15, this was to find alpha raised to power 15, beta raised to power 15, this can be written as the alpha raised to power 14 into alpha, on which further can be written as alpha square raised to power 7 into alpha plus beta square raised to power 7 into beta. And you know alpha square, this is minus 2 iota raised to power 7 into alpha plus 2 iota raised to power 7 into beta. Minus 2 raised to power 7 into minus iota into alpha is minus 1 plus iota plus 2 raised to power 7 into minus iota, because see minus iota raised to power 7, this can be written as, I'm taking the minus outside, this is something like iota raised to power 4 into iota cube, right? This is minus iota cube because iota raised to power 4 is equal to 1. And you know, this is minus iota square into iota. Iota square is equal to minus 1. So this will be ultimately minus iota. Similarly, iota raised to power 7, when you will solve it, you will get minus iota only. And what was beta? It was minus 1 minus iota. Let's write down. So here you have, I'm taking 2 raised to power 7. Iota minus minus has cancelled. 2 raised to power 7 iota minus 1 plus iota plus 2 raised to power 7 iota 1 plus iota. Hope you understood till here. So 2 raised to power 7 iota, I am taking common, minus 1 plus iota plus 1 plus iota. This is going to cancel and you have 2 raised to power 7 into iota into 2 iota. Okay. This will give me 2 raised to power 8 into iota square. What is 2 raised to power 8? This is 256. And iota square is equal to minus 1, which is minus 256. So you have option B as your answer. Hope you got that. Next question number 17. If the equation whose roots are p times the root of this equation is a reciprocal equation, then what is the modulus of p? Okay, so you're given the equation. Let's write down x raised to power 4 minus 2a x cube 4bx square 8ax plus 16 is equal to 0. So let's say this is number 1. So you see it's a raised to power 4 equation. So there will be 4 roots. Let alpha, beta, gamma and delta be 4 roots of this equation. Thus, you know, the product of roots is always constant divided by coefficient of x raised to power 4. So that means alpha, beta, gamma, delta is equal to, constant is 16 upon 1, which is equal to 16. Let's say this is equation 2. Now, the equation whose roots are p times roots of equation 1, we get p alpha, p beta, p gamma and p delta. So let's multiply them. This would be p raised to power 4 into alpha, beta, gamma and delta. This is equal to 1. See, because this is in the question that it is a reciprocal equation whose roots are p times the roots of this equation is a reciprocal equation. So this is the product of the roots over here is equal to 1. For all is a reciprocal equation. So you had p raised to power 4, you will have p raised to power 4 is equal to alpha, beta, gamma and delta. Already have seen that this is the product of them, these roots is equal to 16. So that means p raised to power 4 is equal to 1 by 16, or p will be equal to 1 by 16, the fourth root of it, which will be equal to 1 by 2, of course, plus minus. But I want to take the mod of it, so this will be, I'm ignoring the negative sign, I'll be taking only the positive of it. So this will be 1 by 2. So the answer to the given question is option B. Hope you understood that. Next, question number 18. If the equation whose roots are okay, this is the same question. Question number 18. The total number of three-digit numbers in which the sum of the digits in each of them is equal to 10 is given by. So you want to know all the three-digit numbers such that the sum of the digits always comes out to be 10. All right. So let's first of all assume let the three digits be A, B, and C, where you have A plus B plus C is equal to 10. And of course, one of them must be greater than 0. It can't be greater than equal to 1. It can't be greater than equal to 0. And rest the two can be greater than equal to 0 as well. So I'm taking A is greater than equal to 1, then B is greater than equal to 0, C is greater than equal to 0. Now let's say D is equal to A minus 1. So that will give you A is equal to D plus 1. So this equation now will become D plus B plus C is equal to 10 minus 1. That is equal to 9. Where D is greater than equal to 0. Right? Yeah. So that means here from this equation, D lies between 0 and 8. Of course, right? So here D lies between 0 and 8, and B lies between 0 and 9, and similarly C lies between 0 and 9. Correct? So the total number of three-digit numbers required in the question is total number of three-digit numbers is given by 9 plus 3 minus 1, C 3 minus 1 minus 1, which is equal to 11C2 minus 1, that is equal to 11 factorial upon 2 into 9 factorial minus 1, which is this upon 2 minus 1, which is equal to 55 minus 1, that is equal to 54. So this is the answer to the question. 54, option A stands to be the correct answer. Hope you understood that. Let's move to the next question. Question number 19. All the letters of the word mother are written in all possible ways, and strings of letters without meaning so formed are written in the dictionary order. Then the position of the word THROEM is. See, T comes quite later, like at the 6th position, and all the rest of the alphabets like E, H, M, O, R, they form like they come above T. So how many letters are possible after that? Mother has 1, 2, 3, 4, 5, 6 letters. This is the first one, so that means this is the remaining. This can be filled up in 5 ways. Similarly, the second one also can be filled up in 5 ways. Third one also in 5 ways. Fourth and fifth one also in 5 ways. So the number of possible words, is equal to 5 factorial into 5. Why? See, 1, 2, 3, 4, 5. So 5 factorial into 5, which is equal to 5 into 120, which is 600 ways. Okay, so this is for the first alphabet T. Now you have reached the first alphabet T. The number next one is, the given word was THROEM. Do remember this word. So how many alphabets come before H now? Only one. That is E. So these 2 places are fixed. Then 1, 2, 3, 4. 4 places are left, which can be filled up in 4 factorial ways. And only one such group is possible. So this is 4 factorial into 1. Let's say this is number 1. Let's say this is number 2. So this is equal to 4 factorial is equal to 24. Now the next one, third one, it should be fixed now. See how many alphabets come before R. They are T, H, E, T, H, M, T, H, O. 1, 2, 3, 1, 2, 3, 1, 2, 3. So they can be filled up in 3 ways, 3 factorial ways. So how many are these? The total is equal to 3 factorial into 1, 2, 3, 3. That is equal to 6 into 3, 18 ways. Let's say this is the third equation. Next one. So after this, you have see the three alphabets are fixed. Now the next one. So these three are done. Next is O, and how many alphabets come before O? So they are. So these are the first three ones. Then you have a T H R E and T H R M. So sorry. So before O, you have E and M only. So these can be left two places, can be filled up in 2 factorial ways. So this is equal to 2 factorial into 2, which is equal to 4 ways. Now the last one, the fifth alphabet. So last one now will be this word only. Because see, THROEM. Here you have E, right? And no alphabet actually comes before E, and that's therefore this is the last one which is possible in only one way. So let's say this is equation 4 and 5, right? So the total number, or you can say the position of the word, not ways actually. This is, you can say, these how many not ways. Wait, these are not ways. These are the words which are above the given word. All right. So the total. So position of the word THROEM is given by adding 1, 2, 3, 4, and 5. So this is equal to 6 plus 24 plus 600 plus 24 plus 18 plus 4 plus 1, which is equal to 647. So that means you have option C as your answer. Hope you got that. Next is question number 20. A student is allowed to select at most n books from a collection of 2n plus 1 books. If the total number of ways in which he can select at least one book is 255, then what is the value of n? See, a student is allowed to select at most n books from 2n plus 1 books. Thus, the number of ways he select at least one book is 255. Total ways in which he can select at least one book is equal to 255. The selection is given by the combination concept. So it will be 2n plus 1, which are the total books, plus 2c1, 2n plus 1 c2, 2n plus 1 c3, so on 2n plus 1 cn. Now this is equal to 255, right? You know one thing, that NCR is equal to NCN minus R. So here you can say 2n plus 1, 0 plus 2n plus 1. These are some formulas. Okay, this is one, and this is the second one. One thing I missed writing, 2n plus 1 c0 plus. 2n plus 1 c0 plus this whole till 2n plus 1 cn is equal to, is given by the twice of this is equal to 2 raised to power 2n plus 1, right? So if I take, I'll do one thing. I can write it like 2n plus 1 c0 plus 2n plus. Question number 20. A student is allowed to select at most n books from a collection of 2n plus 1 books. If the total number of ways in which he can select at least one book is 255, then the value of n is See, a student is allowed to select at most n books from a collection of 2n plus 1 books. Correct? So the number of ways in which he can select at least one book, it's given, in which he can select at least one book is given by is 255 according to this question, which means if I write this in the combination concepts, here you have 2n plus 1 C1 plus 2n plus 1 C2 plus 2n plus 1 C3 so on till 2n plus Cn is equal to 255. Now with no two formulas, we know that NCR is equal to NC n minus r. Also, you have 2n plus 1 C0 plus 2n plus 1 C1, 2n plus 1 C2, so on. 2n plus 1 Cn is equal to 2 raised to power 2n plus 1 upon 2. Now let's do the cross multiplication. You will have 2 into, this can be written as 1 plus 2n plus 1 C1, 2n plus 1 C2, so on, 2n plus 1 Cn is equal to, this can be written as 2 raised to power 2n into 2, right? Because bases are same, powers will be added. And of course, this 2 and this 2 will get cancelled. So you will be left with 2n plus 1 C1 plus 2n plus 1 C2 plus 2n plus 1 C3. So on. This is equal to 2 raised to power 2n. Okay, you know this thing, 2 raised to power anything like C0, this is equal to 1. All right, so let's rewrite this. You will have I missed writing this one. Okay, so 2n plus 1 C1 plus 2n plus 1 C2 plus 2n plus 1 C3 till 2n plus 1 Cn is 2 raised to power 2n minus 1. So now if I compare it with this equation, let's say this is equation 1 and this is equation 2. So if I compare both of these equations, you will get, comparing 1 and 2, you have 2 raised to power 2n minus 1 is equal to 255. So 2 raised to power 2n is equal to 256, which gives you 2 raised to power 2n is equal to 2 raised to power 8. That is 2 raised to power n, 2 raised to power 2n was equal to 2 raised to power 8, which gives you 2n is equal to 8 or n is equal to 4. So that's it. You needed this value of n. Option A is the correct answer. Hope you understood that. Next question, number 21. The number of integral terms in the expansion of this given expression is what? You're given the expression as root 3 plus 8th root of 5 whole raised to power 256. See the general term t, and if I say t n plus 1 r plus 1 is equal to, here the n is 256, so this is 256 cr, the first term raised to power 256 minus r, right, 250, 505 raised to power r. This is 8th root of 5 raised to power r. Okay. So this, I'm rewriting, this will be 256 CR 3 raised to power 256 minus R upon 2 into 5 raised to power R upon 8. See now, the number of integral terms in the expansion of. So it is an integer if 256 minus r upon 2 and r upon 8 both are positive integers. So 256 minus r should be greater than 0 and r by 8 should be greater than 0. This gives you r is less than 256. So that means r can have the values. See, r by 8 is greater than 0. So r can have the values as 0, 8, 16, 24, so on till 256. Now, this 256 is equal to 0 plus n minus 1 into d because it's a GP, sorry, it's an AP. This is the first term. First term is equal to 0. Common difference is equal to, see, 8. So this is the last term. So last term is equal to, this is the last term. You know the formula, last term or any term that's equal to first term plus n minus 1 into d. So you have a 256 divided by 8 is equal to n minus 1, which is equal to 32. That gives you n is equal to 33. So that means you have the number of integral terms as 33. Option B is the correct answer. Hope you understood this. Next is question number 22. The expansion of this expression in the power of x is valid if 1 plus x squared raised to power minus 3 by 2. Okay, this is the given expression. Now we know one thing, that expansion of any 1 plus x raised to power n in the power of x is valid if the modulus of x is less than 1, where n is a rational number. So now this will be 1 plus x square. If I'm just solving this, this can be written as 1 by 2 whole, x plus 1 by 2 whole square plus 3 by 4. So this is x plus 1 by 2 whole square plus 3 by 4 minus 1 plus 1, or you can write it as x plus 1 by 2 whole square minus 1 by 4 plus 1. Now, in the expansion of, now the expansion of 1 plus x square minus 3 by 2 in power of x is valid if this minus 1 by 4 is less than 1. That means it lies between x plus 1 by 2 whole square minus 1 by 2. It lies between minus 1 and 1. So this will be minus 3 by 4 less than x plus 1 by 2 whole square less than 5 by 4. Or yeah, 0 less than equal to x plus 1 by 2 whole square less than 5 by 4. See, how is this? You know one thing, this is always greater than equal to 0 for all x belonging to the rational numbers. That means the modulus of this is less than the root of this, which is equal to root 5 by 2. All right. So that means you have option C as your answer. Hope you understood this. Next is question number 23. If x plus 1 plus x raised to power n is equal to this for all n belonging to natural numbers, then what is the value of this expression? Okay, let's write it down. You are given 1 plus x raised to power n, c0, c1, x, c2, x square, so on, cn, x raised to power n. Now integrating on both sides, what we get? Integrating both sides, you get 1 plus x raised to power n plus 1 upon n plus 1 is equal to c0 x c1 x square upon 2 c2 x cube upon 3 so on cn x raised to power n plus 1 upon n plus 1. Now let's put x is equal to 1 on both the sides. What you will get? You will get 2 raised to power n plus 1 upon n plus 1 is equal to c0, c1 upon 2, c2 upon 3, so on, cn upon n plus 1. Therefore, this expression cn upon n plus 1 is equal to 2 raised to power n plus 1 upon n plus 1. This is the answer to the question 2 raised to power n plus 1 upon n plus 1. This is not in the options. So this answer is not in list. Next is question number 24. If x plus 1 upon this is equal to ax plus b upon x squared plus 1 plus c upon x plus 1 plus d upon x minus 1 whole square, then what is the value of a plus b plus c plus d? Okay, so you have x plus 1 upon x square plus 1 into x minus 1 whole square is equal to ax plus b whole divided by x square plus 1 plus c upon x minus 1 plus d upon x minus 1 whole square. So here you have x plus 1 upon this x minus 1 whole square is equal to ax plus b into x minus 1 whole square plus c into x minus 1 into x square plus 1 and plus you will write x square plus 1 whole divided by this will be x square plus 1 into x minus 1 whole square. These things will cancel out and you will have x plus 1 is equal to ax plus b multiplied by x minus 1 whole square plus c into x minus 1 x square plus 1 plus d into x square plus 1. So now let's put dx is equal to 0. You will have 1 is equal to b into minus 1 whole square c into minus 1 plus t. So 1 is equal to b minus c plus t. Let's put x is equal to 1 now. So you will have 2 is equal to d into t, which gives you simply d is equal to 1. If I put x is equal to minus 1, so you will have 0 is equal to 4 into b minus a plus c into minus 2 into 2 plus d into 2, or 0 is equal to 4b minus 4a minus 4c plus 2d. 2b minus 2a minus 2c plus d is equal to 0. 2b minus 2a minus 2c is equal to minus 1. 2 I'm taking common, b minus c minus 2a is equal to minus 1. This is because b minus c is equal to 0 from here. See, d was equal to 1. So from here, 1 is equal to b minus c plus 1, which gives you 0 is equal to b minus c. All right. So that means you have here minus 2a is equal to minus 1, or you have a is equal to 1 by 2. Now let's put x is equal to 2. So you have 3 is equal to 2a plus b plus c into 5 plus d into 5. So you have 3 into 1 by 2 plus b in plus b plus 5c plus 5. So b plus 5c is equal to, you will solve this whole, you will get minus 3, and also you have b minus c is equal to 0. So from both of them, you will get b is equal to minus 1 by 2. Also c is equal to minus 1 by 2. Or you have a plus b plus c plus d is equal to 1 by 2 plus minus 1 by 2 plus minus 1 by 2 plus 1, which is equal to 1 by 2. So that's it. You got your answer as option B. Hope you understood this. Then let's move to the next question, number 25. Question number 25. If sine, let's write down it, 2, you are given 2 sine theta upon 1 plus cos theta plus sine theta is equal to y, then you have to find out the value of this expression. So let's start solving. This can be written as 2 sine theta. I'm rationalizing the denominator. So this will be 1 minus cos theta plus sine theta whole divided by 1 plus cos theta plus sine theta into 1 minus cos theta plus sine theta is equal to y. Or you have 2 sine theta into 1 minus cos theta plus sine theta whole divided by, this will be 1 plus sine theta whole square, because I'm taking 1 plus sine theta as A and minus cos theta as B. Minus cos theta whole square is equal to y. Hope you're clear till here. So next it will be 2 sine theta 1 minus cos theta plus sine theta. I'm opening this. This will be 1 plus sine square theta plus 2 sine theta plus cos minus cos square theta. Sorry, not plus, minus cos square theta is equal to y. Or you have 2 sine theta 1 minus cos theta plus sine theta upon 1 minus cos square theta plus sine square theta plus 2 sine theta is equal to y. Further, this is 2 sine theta, 1 minus cos theta plus sine theta, and 1 minus cos square theta, you know, that's equal to sine square theta, right? You know this identity. So 1 minus cos square theta is equal to sine square theta, and sine square theta plus sine square theta, this will be 2 sine square theta plus 2 sine theta is equal to y. So 2 sine theta 1 minus cos theta plus sine theta. I'm taking 2 sine theta common from here. This will be 1 plus sine theta is equal to y. So this will eventually cancel. And you have 1 minus cos theta plus sine theta upon 1 plus sine theta is equal to y. Okay. So that's it. Now this is equal to y. That means you have option A as your answer. Hope you understood this. Next is question number 26. Again, a trigonometry question. You are given cos pi by 7. Let's write down side by side. I'm starting from here. Cos pi by 7, cos 2 pi by 7, cos 4 pi by 7 is equal to sine 8 pi by 7 upon 8 sine pi by 7. So I'm taking this. This can be written as sine pi plus pi by 7 divided by 8 sine pi by 7. Now this is equal to minus sine pi by 7, because in the third quadrant, this will lie in the third quadrant. Third quadrant sign is negative. So minus sine pi by 7 upon 8 sine pi by 7, they will cancel, and this will be equal to minus 1 by 8. Now you have to get this expression. Let's use this. Sine pi by 14 sine 3 pi by 14 sine 5 pi by 14 sine 7 pi by 14 sine 9 pi by 14 sine 11 pi by 14 and sine 13 pi by 14. So this is sine pi by 14 into 3 sine 3 pi by 14 into sine 5 pi by 14 into see, this will be equal to pi by 2, which is equal to 1 ultimately. Okay. Now this sine 9 pi by 14, I can write it as sine pi minus 5 pi by 14. And 11 pi by 14 can be written as pi minus 3 pi by 14. And 13 pi by 14, it can be written as sine pi minus pi by 14. Hope you understood till here. Now this is sine. See, this will be equal to sine pi, pi minus pi by 14 is equal to sine pi by 14. Correct? So that means this is equal to sine square pi by 14 into sine square 3 pi by 14 into sine square 5 pi by 14. This is because sine pi minus x is equal to sine x. So hope you got till here. So sine pi by 14, I'm writing it as like this into sine 5 pi by 14. This is whole like a square. Okay. Now, further, this is sine. I can write it like pi by 2 minus 3 pi by 7 into sine pi by 2 minus 2 pi by 7 sine pi by 2 minus pi by 7 whole square, which is, see, sine pi by 2 minus x is equal to is equal to cos x. So this is cos 3 pi by 7, cos 2 pi by 7, and cos pi by 7 whole square. Now 3 pi by 7, again I can write it as cos pi minus 3 pi by 4 pi by 7. Cos, I'll leave like this only, 2 pi by 7 cos pi by 7. This whole square, right? So this is equal to minus cos 4 pi by 7 cos 2 pi by 7 cos pi by 7 whole square. Okay, we just calculated this was equal to this thing. This was equal to minus 1 by 8, correct? So you have minus of minus 1 by 8 whole square, which is equal to 1 by 64. So 1 by 64 is the answer to the question. Option C. Hope you understood this. Let's move to the next question, number 27. If f of theta is given by this equation, then what is f of pi by 5? F of theta is cos cube theta cos cube 2 pi by 3 plus theta cos cube theta minus 2 pi by 3. Okay, so then you have to find out f of pi by 5. All right. So see, this can be written as, this is cos 3 theta plus 3 cos theta, right? Plus 1 by 4 cos 2 pi plus 3 theta plus 3 cos 2 pi 3 plus theta plus 1 by 4 cos 2 pi minus 3 theta plus 3 cos 2 pi by 3 minus theta. So on solving this whole thing, you will get 3 by 4 cos 3 theta plus 3 by 4 cos theta plus cos 2 pi by 3 plus theta cos 2 pi by 3 minus theta. This is 3 by 4 cos 3 theta, 3 by 4 cos theta plus 2 cos 2 pi by 3 into cos theta. That's equal to 3 by 4 cos 3 theta, 3 by 4 cos theta plus 2 into minus 1 by 2 cos theta. That's 3 by 4 cos 3 theta plus 3 by 4 cos theta minus this, which will be 3 by 4 cos 3 theta. This is f theta. So f of pi by 5 is equal to 3 by 4 cos 3 pi by 5. Okay, so this will be 3 pi by 4 into root 5 plus 1 upon 4, which is 3 into root 5 plus 1 upon 16. So this is the answer to the question. Let's check with the options. You have option D as your answer. Hope you understood that. Let's move to the next question. Question number 28. Sine h of log 3 plus root 8 is equal to. I would like to discuss a few formulas before starting the question. First is sine hx is equal to e raised to power x minus e raised to power minus x upon 2. Also, one more, that e raised to power log of x is equal to x. Okay. Also one more thing, e raised to power minus log of x is equal to, first of all, e raised to power x raised to power minus 1. So this is equal to x raised to power minus 1 or simply 1 upon x. All right, now let's get back to our question. We had to solve sine h log 3 plus root 8. Okay, this can be written as e raised to power log 3 plus root 8 minus e raised to power minus log 3 plus root 8 whole divided by 2. So this is equal to 3 plus root 8 minus 1 upon 3 plus root 8 whole divided by 2. 3 plus root 8 minus, let's rationalize the denominator. So 3 minus root 8 into 3 divided by 3 plus root 8 into 3 minus root 8 whole divided by 2. 3 plus root 8 minus 3 minus root 8. This is a square plus minus b square whole divided by 2. So this is equal to 3 plus root 8 minus 3 minus root 8 whole divided by 2. So now this is 3 plus root 8 minus 3 plus root 8 whole divided by 2. They will cancel and you have 2 root 8 upon 2, which means root 8, or this is equal to 2 raised to 2 into under root 2, or this is equal to 2 raised to power 3 by 2. So this is answer to the question 2 raised to power 3 by 2, option B. Hope you got that. Next is question number 29. If PQR is an isosceles triangle, PQ is equal to PR. If the radius of the circumcircle of triangle PQR is equal to the length of PQ, then what is the angle P equal to? Okay, here you are given that this is an isosceles triangle. PQR, where PQ is equal to PR. If the radius of the circumcircle of PQR is equal to PQ, then what is angle P? Okay. Fine. Let's say this is equal to R. Let's say you are given that PQ is equal to PR. Let's say this is equal to R. And therefore, these two angles are equal. Angles opposite to the equal sides are equal. So by the sine rule, PQ upon sine of angle R is equal to 2R. Or here you have R, PQ I have taken as R, so divided by sine of R is equal to 2R. This and this will cancel, and you have sine of angle R is equal to 1 by 2. And this is for sine pi by 6, which means angle R is equal to pi by 6. If this is pi by 6, then this is also pi by 6. angle R is equal to pi by 6. So angle Q is equal to angle R is equal to pi by 6, which simply means angle P is equal to pi minus angle Q minus angle R. So pi minus pi by 6 minus pi by 6, which gives you pi minus pi by 3. That is equal to 2 pi by 3. And I turn it into degrees. So this is 2 into 180 upon 3, which is equal to 120 degree. So the answer to the given question is option D. Here's your answer. Hope you got that. Let's move to the next question then. Question number 30. In a triangle ABC, if cos A upon A is equal to cos B upon B is equal to cos C upon C, and the side A is equal to 2, then the area of the triangle ABC in square units is. You are given in the triangle cos A upon is equal to cos B upon B is equal to cos C upon C. Now this is given to you. We also know that A is equal to 2R sine A and B is equal to 2R sine B and C is equal to 2R sine C. Therefore, this equation now will become cos A upon 2R sine A is equal to cos B upon 2R sine B is equal to cos C upon 2R sine C. Right. So that means see 2R is common in all of them, which means simply that tangent of A is equal to tangent of B is equal to tangent of C. So this we know that triangle, from here we know that all the angles actually are equal. That means the triangle is an isosceles triangle. Hence, triangle ABC is equilateral triangle, not isosceles. All the three angles are equal. So this is an equilateral triangle. So you are given A is equal to 2 in the question, right? That means all the three sides are also equal and they are equal to 2 units. That's for sure. And the area of an equilateral triangle is given by the formula of root 3 by 4 into side, which is A in this case, 2. That means you have root 3 square units as your answer. So here it is. Option D is the correct answer. Hope you got that. Next is question number 31. If two vectors A and B, which are perpendicular to each other such that their magnitude, A's magnitude is 8 and B's magnitude is 3, then the value of A minus 2B is equal to. Okay, they are perpendicular to each other. If they are perpendicular to each other, that means their dot product is 0 because they are perpendicular to each other. Also, you are given that magnitude of A is 8 and B is equal to 3. Now, A minus 2B, this is what you need to find out. If I square this, this will be equal to A minus 2B dot A minus 2B. Okay. So this is equal to magnitude of A square plus 4 magnitude of B square plus 4 A dot B, which is actually equal to 0. So this can be written as this. And A's magnitude is 8. So this is equal to 8 square plus 3 square plus 0 into 4 A minus 2B whole square. This is also 1. So 64 plus 36, which is equal to 100. That means A minus 2B whole square is equal to 100, or A minus 2B is equal to 10. That makes option A to be the correct answer. Hope you got that. Next is question number 32. If A and B are non-collinear vectors, then the vector lambda minus 1 into A plus 2B plus 3A into lambda B are collinear, then the set of all possible values of lambda is equal to. Now, first to find the equation of the plane, which is okay, no. There's no plane involved. Wait, let me read it again. Let n be to be non-collinear vectors, then this and this are collinear, then the possible set of values of lambda. Okay, fine. You are given here in the question that A and B are question number 32. If A and B are non-collinear vectors, then the vectors lambda minus A into lambda minus 1 into A plus 2B and 3A plus lambda B are collinear, then the set of all possible values of lambda is equal to. So here in the question, you are given that A and B are non-collinear vectors, right? Collinear vectors. Now, if these two vectors like lambda minus 1 into A plus 2B and 3A plus lambda B, they are collinear. Now, that means lambda minus 1 into A plus 2B. This is equal to some P into 3A plus lambda B, right? So lambda minus 1 minus 3P. I'm concatenating the coefficients of A plus 2 minus lambda P into B is equal to 0 because A and B are non-collinear. So lambda minus 1 minus 3p is equal to 0 and 2 minus lambda p is equal to 0, which gives you lambda minus 1 is equal to 3p, or here you have a p is equal to 2 upon lambda. So let's fill in over here this one, this equation. So lambda minus 1 is equal to 3 into 2 upon lambda, which is equal to 6 upon lambda, or lambda minus 6 upon lambda is equal to 1, which gives you lambda minus 6 is equal to lambda. Lambda square minus 6 minus lambda is equal to 0. So let's split the middle term. You will have minus 3 lambda plus 2 lambda minus 6 is equal to 0. So the two factors will be lambda minus 3 and lambda plus 2 is equal to 0, which gives you lambda may be equal to minus 2 or 3. Thus, the set of all possible value of lambda is minus 2 and 3. That makes option B to be the correct answer. Hope you got that. Next is question number 33. If M is the foot of the perpendicular drawn from the point 1 to minus 1 to the plane passing through this point and perpendicular to this vector, then the length of PM is equal to. Now, first, let's find the equation of the plane passing through 3 minus 2 to 1 and perpendicular to 4i plus 7j minus 4k. So here n dot 4i plus 7j minus 4k is equal to 4i plus 7j minus 4k, 3i minus 2j plus k. So here this is equal to the dot product of xi, yj and zk dot 4i, 7j and 4k. If I'm taking the dot product of both of them, 4 into 3, that's 12 minus 14 minus 4, which is equal to minus 6. So here, from here, you can say 4x plus 7y minus 4z is equal to minus 6, or you have 4x plus 7y minus 4z plus 6 is equal to 0. Now let's try to see it from here. Let's try to make a figure. This is the plane. and this is your point, let's say P. This is the if M is the foot of the perpendicular drawn from this point to the plane passing through this. So let's say this is the point A, which is lying on the plane 3, -2, 1. And this is the point P with the coordinates 1, 2, -1. And so this is the perpendicular. This is point M, which is the foot of the M is the foot of the perpendicular, right? I think, yeah, we have drawn everything. So what do we need to find out in the question is length of PM. Okay, so I need to find out the length of PM. Since M is the foot of perpendicular drawn from P point to the plane whose equation was 4x plus 7y minus 4z plus 6 is equal to 0. So definitely your PM will be equal to 4 into 1, 7 into 2, minus 4, minus 1, plus 6, whole divided by root of 4 square, 16, root of 7 square, 49, root of minus 4 square, again 16. So this is equal to 4, 14, minus plus 4, plus 6, whole divided by root of 81, which is equal to 28 upon 9. So this is the answer to the question. Option D is the correct answer. Hope you understood this. Next is question number 34. Vectors P, A, I, B, J, C, K and Q, D, I, 3, J, 4, K, R, 3I, J minus K. They form a triangle ABC such that P is equal to Q plus R. If the area of the triangle is this, then the sum of the absolute values of ABC is. Now, you are given that these three vectors, they form the triangle ABC such that P is equal to Q plus R, where A, I, B, J, C, K is equal to Q, which is BI 3J 4K plus R 3IJ minus 2K. This gives you AI VJ CK is equal to D plus 3I 4J and 2K. Now on comparing the coefficient of IJK, you have A is equal to D plus 3. Second, you have B is equal to 4 and C is equal to 2. Yeah, you got all the values for this. Now, you are also given area of triangle ABC is given by this, which is equal to half cross product of Q and R. So, this is equal to 5 root 6. If I write in the matrix form, half I, J, and K. Q was D, 3, 4, 3, 1 minus 2. This is equal to 5 root 6. So you have 1 by 2 root of, okay, yeah. So root of this is equal to minus 10 square plus 2 minus 6, yeah. So next is 2D plus 12 square D minus 9 square. This is equal to 5 root 6, or squaring both sides, you will get 1 by 4. This is 100. plus 4d square plus 144 plus that's 48d plus d square 81 minus 18d is equal to 25 into 6, that's 150. All right, so you have a 100 plus 144 plus 81. First of all, I'll add these two. You have 5d square plus 48 minus 18d, that's 30d plus 355. 25 is equal to 150 into 4, 5d square, 30d plus 325 minus 600 is equal to 0. 5d square 30d minus 55 is equal to 0. I'm dividing both sides by 5. So this is equal to 0. Now the two factors will be sorry, this is 325 and this has got to be 55. Okay, yeah. Okay, the two factors will be d square plus 11d minus 5d minus 55 is equal to 0. Or the two factors will be d plus 11, d minus 5, minus 11, comma 5. So for that, if I'm taking d as the corresponding values of a will be, we are already solved that d is equal to d by 3, d plus 3. So if d is minus 11, so a can be equal to minus 8 or 8. These are two possible values of a. Now let's write down, we got all the values. We got a as minus 8 or 8 if I'm taking d as minus 11 or 5. And b, we already solved, it was 4 and c was equal to 2. Now, according to the question, you have to find out a, b and c. So magnitude, right? So that can be, a can be plus minus 8 and b is of course 4 and c is 2. So the answer is equal to 14. That means option A is the correct answer. Hope you got that. Next is question number 35. If B and C are non-collinear vectors, then the dot product of C into A is equal to C dot. Okay. So, okay. If A dot C dot, like this whole thing is true. Wait. Let's read the question again. B and C are non-collinear vectors and C dot C into A is equal to C vector. And this is equal to this. Then you have to find out sine of alpha plus beta. Let's start the question. You are given A dot C B minus A dot B C plus A dot B B is equal to 4 minus 2 beta minus sine alpha into B plus beta square minus 1 into C. Now, on comparing both the sides, we get A dot C plus A dot B is equal to 4 minus 2 beta minus sine alpha, also minus A dot B is equal to beta square minus 1. Let's say this is equation 1 and this one is equation 2. Now, you're given C A is equal to C, which means if I open it, this becomes C dot C into A dot C is equal to C dot C. Okay, which means this is equal to 1. Now I'll take this one in question in this portion. In this equation, number 1. So from equation 1, you will have 1 plus a dot b is equal to 4 minus 2 beta minus sine alpha. Now I'm using second equation. You will get 1 plus 1 plus, this is minus beta square is equal to 4 minus 2 beta minus sine alpha, which gives you beta squared minus 2 beta plus 2 is equal to sine alpha, or beta minus 1 whole square plus 1 is equal to sine alpha. Now it is possible only, this thing is possible only when beta is equal to 1 and sine alpha is equal to 1. So beta is equal to 1 and alpha is equal to pi by 2. Now, what you have to find out was this. So you have this as sine pi by 2 plus 1. You know, sine pi by 2 plus something, this is equal to cos of 1. That's it. This is the answer to the question. Option B, D is the correct answer. Hope you understood this. Next is question number 36. There is a assertion reason problem. The variance of the first n odd natural numbers is given by n minus 1, n squared minus 1 upon 3. And the reason for the same is the sum of first n odd natural numbers is n squared, and the sum of squares of the first n odd natural numbers is equal to this. Okay, so first of all, let's look at the assertion. The variance of the first n odd natural numbers is this, which is absolutely correct. This is right. The reason, the sum of first n odd natural numbers is n square, and the sum of square of the first n odd natural numbers is equal to this. This is also correct. So both are correct. That means this reason is the absolute, is the correct explanation of the assertion. Option A is the correct answer. Next is question number 37. If A and B are two events of the random experiment such that PA union B is equal to PE intersection B, then which one amongst the following four options is not true? You are given PA union B is equal to PA intersection B. Now we know PA union B is equal to PA plus PB minus PA intersection B. That gives you PA plus PB is equal to 2 from here to PA intersection B. Now this is not equal to 1. So therefore, definitely option D is true. Okay. Hope you got that. Next is question number 38. If a group of students, 6 students, including 2 particular students, A and B, stand in a row, then the probability of getting an arrangement in which A and B are separated by exactly 1 student in between them is what? Okay. So there are 2 students, group of 6 students. There are 2 particular students, A and B. They stand in a row, probability of arranging them. So they are separated exactly by 1 student. So first thing, let's say, let us consider ABC such that C separates A and B. Now the choice for C is, it can be 4C one ways, correct? Because out of 6, 2 positions have been occupied by A and B, and the left ones are 4. And C is the one, like it's a one person or one student. So it can be selected. It can be chosen in 4C one ways. And A and B also can interchange their positions. So A and B, they can sit in 2 ways. Now, ABC and other 3 students stand in a row in 4 factorial ways. See, A, B, C, like these 3 positions will be occupied by A, B, C, and how many will be left is 6. Sorry, out of 6, 3 has been occupied, so you will be left with 3 more positions. right? One is you can take them as a group. This group you will take as one position. So total they can be arranged in 4 factorial ways. So the total number of ways, total number of ways to stand in a row such that 2 A and B and separated by one student in between is given by 4 into 2 into 4 factorial ways, right? Now this is the chosen ones. Also, total number of ways to stand without any restriction is 6 factorial because there are 6 students. So required probability is given by 4 into 2 into 4 factorial upon 6 factorial, which is equal to 4 into 2 into 4 factorial, 6 into 5 into 4 factorial. They will cancel, and you have here 4 by 15. So this is the answer to the question. Option B is the correct answer. Hope you understood this. Next is question number 39. A, B, C, D cut a pack of 52 well shuffled playing cards successively in the same order. If the person who cuts a spade first wins the game and the game continues until this happens, then the probability that A wins the game is okay. Fine. So let's say E be the event of anyone cutting a spade in one out first and SP your sample space, right? So the number of terms in E, it will be equal to 13 C1 because if one person cuts a spade first out of 52, you have 13 spade cards. So 13 C1 and total sample space, of course, there are 52 cards and you have to pick up one. So this is 52 C1. Now the required probability of the event E to happen, number of favorable cases upon number of total cases. This is equal to 13 and this is equal to 52, which is equal to 1 by 4. Now, the question is probability that A wins the game. Okay, first of all, this is the probability that the event happens and the probability event does not happen is 1 minus P. So 1 minus 1 by 4, which is equal to 3 by 4. Now, probability A wins the game is P plus Q raised to power 4 into P plus Q raised to power 8 into P, so on till infinity. So here you have, this is a GP with the first term as A and as P and R as your Q raised to power 4. Okay. And if infinity, what is the formula for the sum? This is given as A upon 1 minus R. Here the A is equal to P and 1 minus Q raised to power 4. So this is equal to 1 by 4 upon 1 minus 3 by 4, 4 raised to power 4. So this becomes 1 by 4 multiplied by, or you can say divided by 1 minus 3 by 4, whole raised to power 4, correct? 1 by 4 divided by this thing. 1 minus 3 raised to power 4 is equal to 81 and 4 raised to power 4 is 256. So 1 by 4 divided by 256 minus 81 upon 256. 1 by 4 divided by 175 upon 256. 1 by 4 256, 175. This will cut at 64. So this is your answer. Let's check. You have option D as your answer. Hope you understood that. Next is question number 40. 2 bad eggs are mixed accidentally with 10 good ones. If 3 eggs are drawn at random from this lot in succession without replacement, then the variance of the probability distribution of the number of bad eggs drawn is. Okay. See, there are total 2 bad eggs. And while drawing 3 eggs, we can draw bad eggs 2. And you have to withdraw 3 eggs. Withdraw 3 eggs. Now, what you can have is, first case, 0 bad eggs, 1 bad eggs, or 2 bad eggs. These are the 3 possible cases. Let's say X be random variable denoting number of bad eggs and can be drawn in each draw. So probability that this X is equal to 0 is given by 2C0 into 10C3 whole divided by 12C3. This is equal to 1 into 10 factorial upon 3 factorial into 7 factorial into 12 factorial into 3 factorial into 9 factorial. Let's solve this. This will be equal to 3 factorial and 3 factorial will cancel. And like this will cancel this. You will be left with 12 into 11. And this will be cancelled. You'll be left with 9 into 8. So you have this further. This will cancel at 3, 4, and 2. So this will be 6 upon 11. Similarly, probability that 1 bad egg is drawn is given by 2C1 into 10C2 upon 12C3, which is equal to 2 into 10 factorial divided by 2 factorial, 8 factorial, 12 factorial, 3, and 9. So this cancels. I think I have written everything. Let me check once. Yeah, this 2, 10 to 8. Yeah, okay, done everything. So this cuts at 9. This cuts here. You have 12 into 11 and 3 into 6. Yeah, this is 6 actually. So this cuts at 2. So you have 9 upon 22 over here. Probability that 2 bad eggs are drawn is given by 2C2 10C1 upon 12C3. So this is equal to 1 into 10 factorial, 1 factorial into 9 factorial, 12 factorial into 3 into 9 factorial. They'll ultimately cancel, and this will cancel like 12 into 11. So 6. This will cancel at 2. So you have 1 upon 22 as this. Now let's make the table for this. So here is the value of X. Here is the PI. Here is X PI or X square PI. So you have the 3 values for this. This is 6 upon 11. This is 9 upon 22. And this is 1 upon 22. 0, 9 upon 22, 1 upon 22, 11, sorry. So here is 0 again, 9 upon 22 and 2 upon 11. Right. So now here the mu is equal to sigma I is equal to 0, 1, 2 xpi. So this is 0 plus 9 upon 22, 1 upon 22, which on solving will give you 11 upon 22 or 1 upon 2. Now this is equal to sigma x squared pi minus mu squared. So 9 upon 22 plus 2 upon 11 minus 1 upon 4, right? Yeah. So 18 plus 8 minus 11 upon 44, which is equal to 15 upon 44. So this variance is 15 upon 44. This is the answer to the question. You have option B as your answer. Hope you understood this. Next is question number 41. The locus of the midpoints of the intercepted portion of the tangents by the coordinate axis which are drawn to the ellipse. This is equal to what? Given the equation of the ellipse, let's write down x squared plus 2y squared is equal to 2. If I write it in this form, standard form, this will be x squared plus 2 y squared upon 1 is equal to 1. Now, tangent at a cos theta, b sin theta to the ellipse is x cos theta upon a plus y sin theta upon b is equal to 1. This meets the x's at points a secant theta comma 0 and b 0 b cosec theta. Now let x1 y1 be the midpoint of AB. Therefore 2x1 is equal to a secant theta and 2y1 is equal to b cosecant theta. Thus, this gives you 2x1 is equal to a upon cos theta, or you have a 2 cos theta is equal to a upon x1. And from here you have 2y1 is equal to b upon sin theta, which gives you 2 sin theta is equal to b upon y1. Correct? So let's add them. I'm squaring and adding them. You will have 4 sin square theta plus cos square theta is equal to a square upon x1 square plus the b square upon y1 square. So this is equal to 1. This gives you a is equal 4 is equal to a square upon x1 square plus b square upon y1 square. So 4 is equal to 2 upon x1 square plus the y upon y1 square. Now, why is that? Because here a square is equal to 2 and b square is equal to 1. How? See from here. Yeah, I'm comparing it with the general equation. So general equation was x square upon a square plus y square upon b square is equal to 1. So a square is equal to 2 and b square is equal to 1. So I have just filled in this one in this equation. Okay. Now, hence, locus of x1 comma x2 is 4 upon 2x square plus 1 upon y square. This is equal to 1 upon 2x square plus 1 upon 4y square is equal to 1. This is the answer to the question. Option A is the correct answer. Hope you understood that. Next is question number 42. A line L has intercepts A and B on the coordinate axis. When the coordinate axes are rotated through an angle of alpha, keeping the origin fixed, the same line L has intercepts P and Q on the new axis. Then, which of the following is true? Okay. First of all, let's suppose that the axes are rotated in the anti-clockwise direction through alpha. Let's say axes are because we are not given anything particular, rotated in anti-clockwise direction through angle alpha. The equation of line L with respect to old axis is given by x upon a plus y upon b is equal to 1. Now to find the equation of L with respect to new axis, for new equation of the line L with respect to new axis, we replace x by x cos alpha minus sine y alpha and y by x sine alpha plus y cos alpha. So that the equation of L. So the new equation of L with respect to new x's is given by 1 upon a x cos alpha minus y sine alpha plus 1 upon b x sine alpha y cos alpha is equal to 1. Since the line L intercepts P and Q on the new axis, since new line L intercepts, not at, intercepts P and Q on new axis. So we put P comma 0 and then 0 comma Q. So 1 upon P is equal to 1 upon A cos alpha plus 1 upon B sin alpha, and 1 upon Q is equal to 1 upon A sin alpha minus 1 upon A sin alpha plus 1 upon B cos alpha. Now if we eliminate alpha, we get 1 upon P square plus 1 upon Q square is equal to 1 upon A square plus 1 upon P square. So let's see, it's option D. So this is the correct answer to our question. Hope you understood that. Let's move to the next question then. Question number 53. Two lines L1 and L2 passing through the point 1, comma 2 cut the line x plus y is equal to 4 at a distance of root 6 by 3 units from P. Then the angles made by L1, L2 with the positive x-axis are. Fine, you are given the point P as 1, comma 2. So if I'm using the parametric form, the coordinate of the point at the distance root 6 by 3. Okay, I can write root 6 by 3 as this can be written as root 2 into root 3 upon root 3 into root 3, which will be equal to root 2 by 3 also. Okay, so using parametric form, the coordinates of the point at a distance of root 3 by 2, 2 by 3 is given as 1 plus 2 upon root 3 cos theta 2 plus this sine theta, right? Now you are given that this point lies on this line. This point lies on x plus y is equal to 4. So 1 plus root 2 by 3 cos theta plus 2 plus this is equal to 4, which gives you 3 plus I will say root 2 by 3 and the bracket sine theta plus cos theta is equal to 1, or root 2 by 3 into sine theta plus cos theta, that was equal to 4, and this is like I'm taking 3 on the right hand side, so this is equal to 1. Let's square on both the sides. Squaring both sides, you will get 2 by 3 sine theta plus cos theta whole square. Cos theta whole square is equal to 1, which gives you 2 by 3 sine square theta plus cos square theta plus 2 sine theta cos theta is equal to 1, or you will have 2 by 3, 1 plus 2 sine 2 theta is equal to 1. This gives you 1 plus sine 2 theta is equal to 3 by 2, or sine 2 theta will be equal to 3 by 2 minus 1, that is equal to 1 by 2. And you know, this is for, okay, you can say 2 theta is equal to, or simply you will say theta is equal to half of sine inverse 1 by 2. Correct? So that is either it can be pi by 6 and 5 pi by 6. These are the two possible values. So it can be, theta can be pi by 12 and 5 pi by 12. Then the angles made by L1, L2 with the positive x's are pi by 12 and 5 pi by 12. So this is the answer to the question. Let's check. You have option C as your answer. Hope you understood this. Let's move to the next question, number 44. A pair of straight lines drawn through the origin forms an isosceles right angle triangle at the origin with the line 2x plus 3y is equal to 6. The area in square units of the triangle so formed is. Fine. So here you have the triangle. This is a triangle. Let's say this is A, this is B, this is C. This is an isosceles triangle. So let's say angle B is equal to angle C. It's an isosceles right angle triangle at the origin. So if I'm saying this is the origin, that means this is 90 degree. And of course, these two angles will be equal to 45 degree. Now the given equation of the line is 2x plus 3y is equal to 6. Any line through the origin making an angle of 45 degree with the line of this is of the form any line through the origin making an angle of 45 degree with the given line 2x plus 3y is equal to 6 is of the form y is equal to mx, where tangent of plus minus 45 degree is equal to m minus 2 by 3. See, from here you have 3y is equal to minus 2x plus 6, or y is equal to minus 2 by 3 plus 2, whole divided by 1 plus m into minus 2 by 3. So that's plus minus 1. This is equal to 3m plus 2 upon 3 minus 2m. So this is 3m plus 2. Yeah. So plus minus 1. That was equal to 3m plus 2, which is equal to plus minus 3 minus 2m. this is a big mistake, plus minus 1 is equal to 3m plus 2 upon this, right? So you have 3m plus 2 is equal to plus minus 3 minus 2m. So you have two values, either 3m plus 2 is equal to 3 minus 2m, or 3m plus 2 is equal to minus 3 plus 2m. So from here you have 5m is equal to 1, or m is equal to 1 by 5. So from here you have m is equal to minus 5. These are the two possible values for m. So the other two sides will be other two sides. So from here y is equal to mx. So this will be x upon 5. And from here it will be minus 5x. So you have here x minus 5y is equal to 0, or 5x plus y is equal to 0. Now let P be the perpendicular from A to the base. Let P be the perpendicular from A to the base. 2x plus 3y is equal to 6. So P will be 2 into 0 plus 3 into 0 minus 6 whole divided by 2 square, which is 4, 3 square, which is 9. This is equal to 6 upon root of 30. So now the required area, that's half into base into height. Okay. So this is equal to half into 2p into p, which is equal to half into 2 into 6 upon root of 13 into 6 upon root of 13. They will eventually cancel, and you have 36 upon 13 square unit. This is the answer. See, I have to draw over here. This was your this is, let's say this is point D, and I have, let AD be the perpendicular from A to the base this. Okay, I hope now this is clear to you, right? So that's it. You have option A as well. Hope you understood that. Let's move to the next question. Next is question number 45. The equation of the straight line passing through the point 3, 2 inclined 60 degree with this line is. Given the equation of the line as root 3x plus y is equal to 1. So here the slope, if I write down, it will be y is equal to minus root 3x plus 1. So here the slope, let's say m1, this is equal to minus root 3, correct? So let the slope of the line L, which is passing through the point 3, 2 is, let slope of line L passing through 3, 2 is, that's equal to m2, and they have the angle of 60 degree between them. So tangent of 60 is equal to m2 plus minus of minus root 3. This will be plus root 3 whole divided by 1 minus root 3 into m2. Okay, and tangent of 60 degree, that is equal to this plus minus root 3. So this is equal to m2 plus root 3, 1 minus root 3, m2. So you have m2 plus root 3 is equal to plus minus brackets 1 minus root 3, m2. So you can have this m2 plus root 3 can be equal to 1 minus root 3, m2, or m2 plus root 3 is equal to minus 1 minus root 3, m2. Yeah. So here you have 1, m2 I'm taking common, 1 plus root 3 is equal to this 1 minus root 3. And here you have m2 I'm taking again common, 1 minus root 3 is equal to root 3 minus 1. Minus root 3 minus 1. See, I think I have done a mistake over here. I have not written this root 3. So this whole thing now we will redo. Okay. So now the two possible values will be m2 plus root 3 is equal to positive root 3, 1 minus root 3 m2. And the second one is m2 plus root 3 is equal to minus root 3, 1 minus root 3 m2. So m2 plus root 3 is equal to root 3 minus 3 m2, and m2 plus root 3 is equal to minus root 3 plus 3 m2. Okay. So they will cancel and you will have a 4m2 is equal to 0, which gives you m2 is equal to 0. And from here you have a minus 2 m2 is equal to minus 2 root 3, which gives you m2 is equal to root 3. So these are the two possible values for m2. Now, equation of L passing through 3, 2 is y minus, I'm using y minus y1 is equal to m into x minus x1 only. Okay. So y minus 2 is equal to root 3 x minus 3. Y minus 2 is equal to root 3 x minus 3 root 3, or root 3x minus y plus 2 minus 3 root 3 is equal to 0. So this is the answer to the question, and option B is the correct answer. Hope you got that. Next is question number 46. An equilateral triangle is constructed between these two lines with the base on one line and vertex on the other. The area and square units of the triangle so formed is what of these? So you are given the two lines as this is the first line and the second line. So from here, I can write down y is equal to minus 3 root 3x plus 6. Let's say this is 1. And from here, you have y is equal to minus root 3x minus 9. That's 2. Now, both the lines have the same slope. That is minus root 3. Therefore, they are parallel. So, perpendicular distance between them will be given by C1 minus C2 root of 1 plus m square. So this is equal to 6 minus of minus 9, 1 plus minus root 3 square. That is 15 upon 2. Now, then in the question, let's get back. Equilateral triangle is constructed between the lines with the base as one line and vertex on the other line. So let's make that equilateral triangle now. These are the two lines. Let's make an equilateral triangle. Okay, let's take any. I'm taking y is equal to minus root 3x minus 9 as this line. Y is equal to minus root 3x plus 6 as the another line. So this is an equilateral triangle. So this is 60, this is 60 and 60 again. A, B, C. So these three lines, they are equal. Okay, let's say this is a perpendicular, drop it. So AD is the perpendicular to BC. Okay. And we just calculated this AD is equal to 15 by 2. Also, we know this is an equilateral triangle. So AB is equal to BC is equal to AC. Let's say this is equal to A. All right. So DC is equal to BC upon 2. You know, the midpoint, the perpendicular is actually the median to the triangle, to the line BC. So this is equal to BC upon 2 or A upon 2. That means, okay, I'm taking the triangle ADC. So in the triangle ADC, tangent of 60 degree is equal to AD upon TC. AD we calculated, it was 15 upon 2 and this is equal to A upon 2. First of all, 2 and 2 will cancel. Tangent of 60 degree is equal to root of 3. So root of 3 into A is equal to 15, which gives you A is equal to 15 can be written as 5 into 3 upon root 3. So this is equal to 5 root 3. That is the value for A. We got this side. Now, what we need to find out is area of the triangle. We already got the side. 5 root 3. Area is given by, area of an equilateral triangle is given by equilateral triangle is root 3 by 4 into side square, root 3 by 4 into side was equal to 5 root 3 square, 25 into 3. So this is equal to 75 upon 4 into root 3 square units. So this is the answer to the question. Okay, we don't have anything like that, but we have 4 into root 3 in the denominator. If I do one thing, 75 into root 3 into root 3 upon 4 into root 3, this will be 75 into 3 upon 4 root 3, that is equal to 225 upon 4 root 3. So you have option C as your answer. Hope you got that. Next is question 47. If theta is the acute angle between the lines joining the origin to the point of intersection of the curve, this and the straight line this, then cos theta is equal to. You're given the equation of the line as this and the equation of the curve is this. Plus x plus 3y plus 1 is equal to 0. Let's say this is 1 and 2. So now from the equation 1, we have this. I'm taking x plus y is equal to minus 2 or 1 is equal to minus x minus y upon 2. So from equation 2 now, x square plus xy plus y square plus x plus 3y plus 1 is equal to 0. You have x square plus xy plus y square or you have x square plus xy plus y square. So I'm filling this thing over here. On 2 plus 1 square. So I'm writing as this. Let's solve it further. You will have x square plus xy plus y square. X square minus xy upon 2 minus 3 xy 3y square upon 2 plus x square plus y square plus 2xy okay upon 4. This is equal to 0. So multiplying both sides by 4, you have 4x square, 4xy, 4y square minus 2x square minus 2xy minus 6xy minus 6y square x square y square plus 2xy is equal to 0. You have 3x squared minus y squared minus 2xy is equal to 0. So writing it properly, you have 3x squared minus 2xy minus y squared is equal to 0. On comparing it with the general equation, ax squared to hxy by square is equal to 0. You have a is equal to 3, b h is equal to minus 1, and b is equal to minus 1. Now let's say theta be that acute angle. So cos theta is equal to modulus of a plus b whole divided by a minus b whole square plus 4h square, or 3 minus 1 4 square 4 into minus 1 square, which is equal to 2 upon root of 20, that is equal to this. So this is the answer to the question, 1 upon root 5. You have option B as your answer. Hope you understood this. Let's move to the next question. Question number 48. If a circle passing through 1 comma minus 2 and this as its diameter, then the radius of the circle is. Okay. So now the given two diameters are, let's write down a minute. So the first one is x minus y is equal to 2. Second one, 2x plus 3y is equal to 14. These are two diameters. Let's say this is 1 and this is 2. Now, on solving them, both the diameters, because they definitely are going to have your center as their point of intersection, correct? Let's solve it. I'll multiply this one with 2. So you have 2x minus 2y is equal to 4, and 2x plus 3y is equal to 14, minus minus minus. So you have minus 5y is equal to minus 10, or y is equal to 2. For y is equal to 2, you will get the value of x is equal to 4. So x is equal to 4, y is equal to 2. That means this is the center, because the two diameters of a circle, they definitely will intersect at the center of the circle. So the center of the circle is given by 4 comma 2. Now the equation of the circle will become equation of circle will be equal to x minus 4 whole square plus y minus 2 whole square is equal to radius square. Now it's given that this passes through 1 comma minus 2. Let's go for this. So I'm putting at 1 comma minus 2. You have 1 minus 4 square minus 2 square is equal to r square, or you have 9 plus 4 square is 16 is equal to r square, which gives you r is equal to plus minus 5. Definitely you can't have the radius as negative, and it's got to be the 5, positive 5, option D. Hope you understood this. Let's move to the next question then. Question number 49. The equation of the circle whose diameter is the common chord to these two circles is which of these options? Students, before starting with this question, is a quick reminder to visit our website www.examsnet.com. This site is a great place for you to practice for your entrance exam question papers and many more similar type of entrance exam question papers. For a better preparation of your exams, you must download our app. The link is available in the description box. So very best of luck. Now let's continue with the question number 49. You're given the equation of the two circles. Let's say this is S1 and this is S2. Now the common chord is the radical axis. Let's say this is equation 1 and this is equation 2. The common chord is the radical axis of both the equations, and equations 1 and 2, and the equation of radical axis is given by equation of radical axis is given by S1 minus S2 is equal to 0, which gives you x squared plus y squared plus 2x plus 3y plus 1 minus x squared minus y squared minus 4x minus 3y minus 2 is equal to 0. These will cancel out, and you have, when this will cancel, you have minus 2x minus 1 is equal to 0, which gives you 2x plus 1 is equal to 0. Now let's say this is S3. All right. Now the equation of any circle which is passing through the equation of any circle passing through the point of intersection of equation 1 and 3. Let's say this is equation 3. Intersection of equations 1 and 3 is given by S1 plus lambda S3 is equal to 0, where lambda is the constant. Okay, so that means it's given by x squared plus y squared plus 2x plus 3y plus 1 plus lambda 2x plus 1 is equal to 0. Or I'm concatenating the x coefficient terms, which will give you x squared plus y squared plus 2 plus 2 lambda x plus 3y plus 1 plus lambda is equal to 0. Let's say this is equation 4. Now from here, what is the center of the circle? For this center of circle, you know that is given by minus g minus f, where g is half the coefficient of x and f is half the coefficient of y. Half the coefficient of x will be equal to minus lambda minus 1, right? And half the coefficient of y will be equal to minus half the coefficient of y will be equal to 3 by 2. There's a minus. So now for circle given by equation 4, this is a chord. Now, this chord will be the diameter of the circle. This chord will be the diameter of the circle if center of equation 4 lies on third equation, right? Which was your third equation, that was 2x plus 1 is equal to 0. So this makes 2 into minus lambda minus 1 plus 1 is equal to 0. So minus 2 lambda minus 2 plus 1 is equal to 0. That gives you lambda is equal to minus 1 by 2, right? Now the equation of the circle whose diameter is the common chord of equations 1 and 2 is given by equation, a minute. All right, equation of circle whose diameter is the common chord of equation 1 and 2 is given by x square plus y square. Now the lambda, it was this 2 plus lambda, 2 plus 2 lambda 2 plus 2 lambda x plus 3y plus y is equal to 0. This gives me x square plus y square. This will be x minus 1. So this will be plus x plus 3y plus 1 by 2 is equal to 0. Multiplying both the sides by 2, you will get 2x square plus 2y square plus 2x plus 6y plus 1 is equal to 0. So this is the answer to the question. Let's check which option you have. Option A stands to be the correct answer. Hope you understood that. Next is question number 50. The number of common tangents to the circle this and this is. So in this question, you have to find out how many common tangents are there to both of these circles. So let's write down the equation. X square y square minus 2x minus 6y plus 9 is equal to 0. And the second one stands to be x square plus y square plus 6x minus 2y plus 1 is equal to 0. Here the center will be equal to minus g minus f. So minus half the coefficient of x, this will be 1, minus half the coefficient of y, it will be 3. And for this one, the radius will be given by, the formula for the radius. So let's write it over here. Radius is given by root of g square plus f square minus c. So that will be given by root of 1 plus 3 square, that is 9, minus c. So that's equal to 1 only. Okay. Okay, so now the next thing for the second circle, you have the center, let's say this is C1 and let's say this is the center C2. It is given by minus half the coefficient of x minus half the coefficient of y, and the radius will be given by g square, which is 9, x square, s square, which is 1, minus of 1, which will be equal to 3. So I got the radius and the center for both of them. So let's see the distance between the two centers, that is C1, C2. This will be given by root of 1 plus 3 square plus 3 minus 1 square, which will be equal to 16 plus 4, which is root of 20. Also, let's see the R1 plus R2 radius. That's 4, right? Or simplified, say it in the root term, so that is root 16. So clearly from here and here, you see that C1, C2 is greater than R1, R2. Correct? And the circles are non-intersecting because the distance between the circles, centers is greater than the sum of their radius. So the circles are non-intersecting. Clearly, circles are non-intersecting. So there will be 4 common tangents. Correct? Now transverse common tangents are transverse common tangents are tangents drawn from P which divides C1, C2 internally in the ratio of, what is the ratio between the radius? 1:3. So the coordinates of P are, what were the two centers? It was 1, 3 and minus 3, 1. So C1 was 1, 3 and C2 was minus 3, 1. All right. Okay, so that's given by 1 into minus 3 plus 3 into 1 divided by 3 plus 1. And 1 into 1 plus 3 into 3 upon this. So this will give you 0 and 5/2. Now the equation of the tangent through this point. Equation of tangent through P, which is this point, is given by y minus y1 is equal to slope, let's say that m x minus 0, which gives you y minus 5/2 is equal to mx, or okay, mx minus y plus 5/2 is equal to 0, right? Now, if I say this is the point P, let's say this is the point P. If I draw a tangent from this point, and always the tangent falls perpendicularly with the radius of the circle, correct? And for the circle 1, the radius was equal to 1, and this equation is, this center is given by 1, 3. Where it is? Yeah, 1, 3. Let's write it over here. For the circle C1, circle 1, radius is equal to 1, and center is this, and this is the equation of the tangent. So what will be the radius equal to? Radius is the distance, perpendicular distance between the center and this line. This will be equal to m into, what was the equation of the line? Let's write down x square plus y square minus 2x minus 6y plus 9 is equal to 0. So m into, sorry, m into, sorry, not, I don't need the line, this equation, m into 1 minus 1 into 3 and plus 5 by 2 whole divided by root of 1 plus m square. Right, here I'm using the distance formula, perpendicular distance formula, which is given by mod of a x1 plus b y1 plus c is whole divided by root of a square plus b square. Okay, so this formula is being used over here because the radius is the perpendicular distance from the center on this tangent. So this becomes 1 is equal to m minus 3 plus 5 by 2 whole divided by 1 plus m square under the root. So 1 plus m square under the root will be equal to m minus 1 by 2. Okay, squaring both the sides, you will get 1 plus m square is equal to m square plus 1 by 4 minus 2m. M square will cancel, and you will have 2m plus 3 by 4 is equal to 0, or m will be equal to question number 50. The number of common tangents to these two circles is given by. Let's write down the equation of the circles. This is x square plus y square minus 2x minus 6y plus 9 is equal to 0. The center of the circle, which is minus half the coefficient of x, 1 minus half the coefficient of y, that is 3. And the radius is given by the formula, you know, I'm writing it over here. The radius is given by root of g square plus f square minus c. So g is 1, f is 3. Actually minus 3, so but I'm writing like minus 3 square is equal to 9, and minus of 9. So here the radius of the circle is equal to 1, and the second equation of the circle is x square plus y square plus 6x minus 2y plus 1 is equal to 0. Here the center is given by minus 3, 1, and radius will be given by root of 9 plus 1 minus 1, that is equal to 3. So these are the two circles, and see, let's find out C1, C2, the distance between the two centers. This is given by root of 1 plus 3 square plus 3 minus 1 square, which is equal to 16 plus 4. That's root 20. And let's find out the R1 plus R2. That is, see, if I'm having the two circles, this is the center C1, and let's make it a bigger one. These are the two circles. So this is R1, this is R2, and of course, this is a C1 center and C2 center. R1 plus R2, that's given by 4, and if I write in the root terms, this is root 16, and clearly you see one thing, C1, C2 is greater than R1, R2. R1 plus R2, which means that the circles are non-intersecting, of course, then only this is possible. Therefore, circles are non-intersecting, therefore there will be 4 common tangents. Now, what are the transpose common tangents? They are tangents drawn from point P, which divides C1, C2 internally in the ratio of radii, 1:3. So what will be the coordinates of P now? From here, coordinates of P will be given by what was C's coordinates? It was 1, 3, and C2 had the coordinates as -3, 1. Okay, so it will be given by 1 into -3 plus 3 into 1 upon 1 plus 3, 1 into 1, 3 into 3 upon 1 plus 3, which is equal to 0, 5/2. Now the equation of the tangent from this point, equation of tangent passing through this point, passing through this point. If I take the slope as m, this will be given by y minus 5/2 is equal to, I'm taking the slope as m, x minus 0, which gives you y minus 5/2 is equal to mx, or you have mx minus y plus 5/2 is equal to 0. Now this is the equation of the tangent from the point P. So if I'm taking this the point P, let's say this is the point P. So this is the equation of the tangent, and you know it falls perpendicularly, right? Therefore, radius, or you can say R1, radius for the circle 1. If I'm taking circle 1, the center is given by, it was 1, 3. Yes. And the radius was equal to 1. So radius is actually the perpendicular distance from the center to this line. And what is that formula? Perpendicular distance from a point to a line is given by the mod of ax1 by1 plus c divided by root of a square plus b square. Okay. So here a is m, and this m into 1, and here is coefficient of y as -1 into 3 plus 5/2 divided by root of 1 plus m square. Let's solve it. Radius is equal to 1. This is equal to m minus 3 plus 5/2 whole divided by this. So you have root of 1 plus m square is equal to m minus 1/2. Let's do squaring on both the sides. So this is equal to minus m. Here was m square supposed to be. So these two will cancel, and you will have m is equal to minus 3/4. Okay. Now, thus, x is equal to 0 is a tangent, and y minus 5/2 is equal to minus 3x by 4, which will be equal to 3x plus 4y minus 10 is equal to 0. This is your another tangent. Okay. Now, second thing, direct common tangents. These are the tangents drawn from the point Q, which divides externally in the ratio 1:3. So direct tangents are tangents drawn from Q, that is 3, 4. Now proceeding as the same way as transverse tangents, their equations will be y is equal to 4, and from there you will get 4x minus 3y is equal to 0. So in the whole thing, how many total common tangents did you get? 4. So there are 4 total common tangents. Hope you understood that. So option D stands to be the correct answer. Next is question number 51. The pole of the straight line this with respect to this circle is given by. So you are given the straight line as 9x plus y minus 28 is equal to 0, and the equation of the circle 2x square 2y square minus 3x plus 5y minus 7 is equal to 0. Dividing both sides by 2, you have x squared plus y squared minus 3 by 2x plus 5 by 2y minus 7 by 2 is equal to 0. Let's say this is equation 1 and this one is equation 2. Let HK be the pole of given line. So equation 1 with respect to the circle which is given by equation 2, the equation of the polar will be Hx plus ky minus 3 by 4 x plus h 5 by 4 y plus k minus 7 by 2 is equal to 0. Now I'm concatenating the x coefficients. You will have x into h minus 3 by 4 y k plus 5 by 4 minus 3 by 4 h 5 by 4 k minus 7 by 2 is equal to 0, or x into 4h minus 3 y 4 k plus 5 minus 3h 5k minus 14 is equal to 0. This equation and this equation and the equation 1, which was 9x plus y minus 28 is equal to 0. They are the same lines. Okay, this and this are same lines. So you have 4h upon 3 4h minus 3 upon 9 is equal to 4k plus 5 upon 1 is equal to minus 3h plus 5k minus 14 upon minus 28 is equal to, say, lambda, which is h is equal to 9 lambda plus 3 upon 4 k lambda minus 5 upon 4 and minus 3h plus 5k minus 14 is equal to minus 2 lambda. All right. Now, from here, minus 3 into 9 lambda plus 3 upon 4 plus 5 lambda plus minus 5, sorry, lambda minus 5 upon 4 minus 14 is equal to 2 lambda. Okay, I'm filling in this equation. So you will get this. Let's solve it further. That's equal to minus 9 minus 27 lambda plus 5 lambda minus 25 minus 56 is equal to minus 112 lambda, or minus 22 lambda minus 90 is equal to minus 112 lambda, which is 90 lambda is equal to 90, or you have lambda is equal to 1. Therefore, now h is equal to 3 plus 9 into 1 upon 4, which is equal to 12 upon 4, that is equal to 3. And the k 1 upon this, that's equal to minus 1. Therefore, h comma k is equal to 3 comma minus 1. So that's it. This is the answer to the question. You have to find out the pole of the straight line with respect to this. That is option 3 comma minus 1, option D. Hope you understood this. Next is question number 52. The equation of the line perpendicular radical axis of the two circles is given. Equation of the line perpendicular radical axis of the two circles, this, and passing through 1 comma 1 is Which of these options? Now you are given the two equations. Let's say this is circle 1 and let's say this is circle 2. Now equation of the radical axis of the two circles is given by radical axis equation is S1 minus S2 is equal to 0, which gives you x square plus y square minus 5x plus 6y plus 12 minus x square minus y square minus 6x plus 4y plus 14 is equal to 0. I have these two cancelled. You will have minus 11x plus 10y plus 26 is equal to 0, or 11x minus 10y minus 26 is equal to 0. So let's say this is equation 1. Okay. Now from here, slope of this line is, slope will be given by 10y is equal to 11x minus 26, or y is equal to 11 by 10x minus 26 by 10, which gives you slope. Let's say that's equal to m, and it is given by 11 by 10. Let's say this is equal to m1. Now slope of the perpendicular line will be equal to slope of perpendicular line, which is equal to m2. That will be equal, the product of the slopes is equal to -1. So this will be equal to minus 10 upon 11. Correct. Now equation of line will be y is equal to minus 10 upon 11x plus c. It's given in the question that it passes through 1, 1. Since it passes through 1, 1, so you have 1 is equal to minus 10 upon 11 into 1 plus c, which gives you c is equal to, okay, wait, 1 is equal to minus 10 upon 11 plus c. That gives you c is equal to 1 plus 10 upon 11. That's equal to 21 upon 11. Now, therefore, equation will be, now the equation will be, it was initially y is equal to minus 10 upon 11x plus c. So now the equation will be y is equal to minus 10 upon 11x plus 22 by 11. That gives you 11y is equal to minus 10x plus 21, which gives you 10x plus 11y minus 21 is equal to 0. 10x plus 11y is this option C. Hope you understood this. Next is question number 53. If the angle between these, if the angle between the circles this and this is 60 degree, then what is C equal to? Fine, you are given the two circles and you are given that the angle between the two circles is 60 degree. All right, so let's say this is equation 1 and let's say this is equation 2. So from 1, you have for the first circle, the center is given by minus half the coefficient of x minus half the coefficient of y, and for this the circle center is given by 2, 1. And what is the radius given in this case? It's root of 1 plus 4 minus c, that is equal to root of 5 minus c. And the second radius is given by root of 4 plus 1 minus of 4, that is equal to 1. I got both the centers, I got both the radii. So let's say now find out C1, C2. C1, C2 will be given by 1 minus 2 square plus 2 minus 1 square. That is equal to root of 2. Let's say this is equal to d. So d square is equal to 2. You are given theta is equal to 60 degree. And you know cos of angle between the two circles is equal to r1 square, r2 square minus d square upon 2 r1 r2. So cos of 60 degree is equal to 5 minus c plus 1 minus 2 whole divided by 2 into this. So This is equal to 1 by 2. That's equal to 4 minus c upon this. 2 and 2 will cancel from here also. You have root 5 minus c is equal to 4 minus c. Let's do squaring on both the sides. You will get 5 minus c is equal to a square plus b square minus 2ab. So you have here c square minus 7c plus 11 is equal to 0. So I'm using the quadratic formula to find the roots. That's the value for c. It will be given by, you know the formula. It is minus b plus minus b square minus 4ac upon 2a. So this is equal to 7 plus minus root of 49 minus 44 whole divided by 2. So this is 7 plus minus root of 5 upon 2. That's the answer to the question. Option C is the correct option. Hope you got this. Next is question number 54. The normal at a point of the parabola y square is equal to 4x passes through 5, 0. If there are two more normals to this parabola passing through 5, 0, then the equation of one of these normals is equal to. Find your given the equation of the parabola as this. Thus, the equation of normal to this parabola will be given by y is equal to mx minus 2m minus m cube. Since any normal equation to the if I'm having the general parabola y square is equal to 4ax, so normal equation to the parabola is given by normal equation is y is equal to mx minus 2am minus am square. Okay, so a is 1 in this case. This is a is 1 in this case. So the equation of the normal will be equal to this. Let's say this is equation 1. Thus equation 1 it's given that it passes through 5, 0. So this equation now will be 0 is equal to 5m minus 2m minus m cube. I'm taking the m common, so m will be m square plus 2. This is actually 3m, so I can write it like 3 is equal to 0. So either m is equal to 0 or wait, here was supposed to be minus. I'll rewrite this thing. Wait. So this is equal to m cube plus 2m minus 5m is equal to 0, or m cube minus 3m is equal to 0. I'm taking common, m square minus 3 is equal to 0. So from here you have m is equal to 0 or m square is equal to 3, which gives you m's value as plus minus root of 3. Therefore, the equation of the normal passing through 5, 0, equation of normal passing through 5, 0 and slope root 3 is given by y minus 0 is equal to root 3 x minus 5, or root 3x minus 5 minus 5 root 3 is equal to 0. Okay, so this is the equation to the line. I think we got to our answer. This is what we needed to find out in the question. So therefore, you have option D as your answer. Root 3x minus y minus 5 root 3. Let's check. Yes. Option D is your correct answer. Hope you understood this. Next is question number 55. Equation of common tangents to this parabola and this circle are given by. So you're given two things over here. First of all, you're given the parabola, which is y square is equal to 16x, and the circle x square plus y square is equal to 8. Here the center is obviously origin, and the radius is the root of 8, which is 2 root 2. Correct? Yeah. So let's say this is equation 1. And let's say this is equation 2. Now equation of tangent to the parabola is given by y is equal to mx plus 4 upon m. See here, a is equal to 4. So this is given by 4 upon m. And also radius is equal to length of perpendicular from the center to the tangent. Correct? So 2 root 2 is equal to mod of center was origin, so 0 plus 0 minus 4 upon m whole divided by 1 upon root of n square. So let's do squaring on, first of all, let's write 2 root 2 is equal to 4 upon m upon this, which will be 2 root 2 into root 1 plus m square is equal to 4 upon m. Let's do squaring on both sides. So 8 into 1 plus m square is equal to 4 upon m square, which will give you ultimately 8m square plus 8m raised to power 4 is equal to 4. Dividing both sides by 4, you have 2m raised to power 4 plus 2m square plus 1 is equal to 0. Yeah, wait. I did a mistake over here, and here I squared, so it was supposed to be 16, right? Because I squared both the sides. So this was supposed to be 16. Now I'll be dividing both the sides by 8. You have m raised to power 4 plus m square minus 2 is equal to 0. Now it will be m raised to power 4 plus 2m square minus m square minus 2 is equal to 0. M square plus 2 m square plus 2, yeah, is equal to 0. So now the two factors will be m square minus 1, m square plus 2 is equal to 0. Now for sure, m square plus 2 cannot be equal to 0 because square is always a positive term. So therefore, m square minus 1 is got to be 0, or m will be equal to plus minus 1. Now, when m will be equal to 1, what will be y equal to? It will be x plus 4, and 1 it will be minus 1. Y will be equal to minus x minus 4. That's it. So this is the two equation of the common tangents. That means you have option D as your answer. Hope you got that. Next is question number 56. Product of the length of perpendiculars drawn from two foci to this ellipse is equal to 1 to the tangent at any point on the ellipse is. You're given the equation of the ellipse as x squared upon 9, which I can write it as like 3 square. Right? So here you have a is equal to 3 and b is equal to 5. Equation of the tangent at any point will be given by equation of tangent at any point will be 3 cos theta, 5 sin theta. Yeah, on the ellipse is given by x upon 3 cos theta, y upon 5 sin theta is equal to 1, or you have 5x cos theta, 3y sin theta minus 15 is equal to 0. Okay, now the product of the perpendicular from the point 3e comma 0 and minus 3e comma 0 on this tangent is, it will be 5 into this. It will be 15e cos theta minus 15 minus 15e cos theta minus 15 whole divided by 25 cos square theta 9 sine square theta. So let's open up the brackets. You will have minus 2 to 5 e square minus 2 to 5 e cos theta plus 2 to 5 e cos theta plus 225. Okay, so these two will cancel out. Whole divided by 25 cos square theta plus I can write it like 25 1 minus e square cos square theta. So I'm taking 225. One thing I forgot to write here was cos square theta. Okay, so I'm taking 2 to 5 common from here. That will be 1 plus, not plus, it's minus e square cos square theta whole divided by 25. I'm taking again common. It will be 1 minus e square cos square theta. Question number 56. The product of the length of the perpendiculars drawn from the two foci on the ellipse, this is equal to 1 to the tangent at any point on the ellipse is. So you're given the equation of the ellipse as x square upon 9 plus y square upon 25 is equal to 1. Here a square is equal to 9. That gives you a is equal to 3 and b square is equal to 25, which gives you b is equal to 5. So clearly you see that a is less than b. Therefore, the two foci will be given by 0 plus minus BE. So that means the two foci will be 0, 5E and 0 minus 5E. Correct? Now the equation of the tangent. Equation of tangent at any point. I'm writing the point in the parametric form. At any point A, which is 3 in this case, cos theta, and 5 sine theta on the ellipse is given by x upon 3 cos theta plus y upon 5 sine theta is equal to 1. That makes 5x cos theta plus y, 3y sine theta is equal to 15, which I'll take on this side, left hand side. That will make minus 15 is equal to 0. Now, the product of the required question, according to that, the product of perpendicular from the two foci, which is given by these 2 points from foci on the tangent is, that is given by, here the 2 points, this is the equation of the line, and the 2 points are 0, 5e and 0 minus 5e. That makes this as this will be 5x into 0, so this will be 0, 5. Okay, let's write down 5 cos theta into 0 plus 3 sine theta into 5e minus 15. This is for the first one, divided by the root of 5 cos theta whole square plus 3 sine theta whole square. This is multiplied by 5 cos theta into 0 plus 3 5 cos theta into 0 plus 3 sine theta into minus 5e minus 15 whole divided by root of 5 cos theta square 3 sine theta square. Hope you understood till here. Now let's multiply them. You have to find this product actually. Now this will be 0, 15 sine theta minus 15. This will be multiplied by minus 15 sine theta minus 15. Okay, yeah. Whole divided by root will cancel because it is having the same terms. This will be 25 cos square theta plus 9 sine square theta. Hope you got till here. Now let's multiply the numerator side. This is equal to minus 2 to, see, this is something a minus b. If I'm taking this minus outside, let's do that. So I'm taking the minus outside. This will be 15 sine theta plus 15 sine theta minus 15 whole divided by 25 cos square theta. And okay, I'll break up this 9 as this can be written as 25 1 minus e square sine square theta. Now how is this possible? Let's discuss it over here. You know the formula for e square is equal to 1 minus a square upon b square. A square in this case is 9 and b square in this case is 25. So this gives you a square upon b square is equal to 1 minus e square. I had this a square. This 9 is actually nothing but a square. So a square is equal to b square into 1 minus e. In this question, a square is 9 and b square is 25. So 9 is equal to 25 into 1 minus e square. Hope you understood this thing. So I have just used this in place of 9. Hope you got that. Now, this will be a plus b into a minus b. That gives you minus 225 sine square theta minus 225 whole divided by let's open up this. So 25 cos square theta plus 25 sine square theta minus 25 e square sine square theta. Over here, I'm taking 225 outside. So this will be 1 minus, and I'm also using this minus inside. 1 minus, here I forgot to write down e square. Wait, I have not written e anywhere. Yeah, I have forgot. So sorry for this. E was supposed to be everywhere. Oh, it was not here, sorry. And here also, here, 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 and yes. So it will be e square sine square theta whole divided by 25 will be taken common, sine square theta plus cos square theta minus 25 e square sine square theta. So 225 1 minus e square sine square theta whole divided by, I'm again taking, this is 25 minus 25 e square sine square theta, because you know this is equal to 1 sine square theta plus cos square theta. So 225 1 minus e square sine square theta whole divided by 25. I'm taking common 1 minus e square sine square theta. This will cancel and this will cancel at 9. So you have this answer, 9. The product of the tangent, product of the length of the perpendiculars drawn from the two foci of this ellipse to the tangent at any point is 9. Option D stands to be the correct answer. Hope you got this question. Next is question number 57. Tangents are drawn to the ellipse. This at all the ends of its latest rectum. The area of the quadrilateral so formed in square units is, you're given the equation of the ellipse as x square upon 9, y square upon 5 is equal to 1. So in this question, see over here, A is In this question, obviously A is greater than B, so E will be given by 1 minus 5 upon 9, which will be equal to 2 upon 3. Correct? So now AE will be equal to nothing but A is in this question, A is equal to 3. So AE will be given by 3 into 2 by 3, which is equal to 2 only. Now, equation of tangent at the point 2 comma 5 by 3 is given by, see the general equation for the tangent, that is given by x upon a plus y upon b is equal to 1. Here a is equal to 3 and b is equal to root of 5. Question number 57. Tangents are drawn to this ellipse at all the ends of the latest recta. The area of the quadrilateral so formed in square units. Let's try to make the figure first. This is your coordinate axis. So this is your ellipse, because here the A is greater than B. A is 3 and B is root of 5. Now this is the given ellipse. Now the question, tangents are drawn to the ellipse at all the ends of its latest rectum. So let's draw these two. Let's say this is S and S dash. Now tangents are drawn at this point. Also from here. At this point. I'm not good at so good at drawing actually. Wait. Right? It may not look like a straight line, but it's supposed to be a straight line. All right. So this is somehow the your quadrilateral. Let's name it A, B, C, and D. This is a given quadrilateral. So the coordinates of this latest rectum, it will be given by AB, and this one will be B square upon A. This one will be AB minus B square upon A. This one will be minus AEB square upon A, and this one will be this point. This is the point. Yeah, this point. And this point will be given by minus AE minus B square upon A. So let's get back to our question. The given equation of the ellipse was this. So over here, because A is greater than B, so E will be given by root of 1 minus B square upon A square, which is equal to root of 4 upon 9. That is nothing but 2 by 3. Also, the value of AE will be, A was equal to 3. I just told you this. So this is equal to 2. You got the value of AE and E. Now, the equation of the tangent at this point, AEB square upon A, which is 2 5 by 3 is given by, see the equation is given by x into x1 upon a square, y into y1 upon b square is equal to 1. So x into x1, that is equal to 2 upon a square plus y into b 5 upon 3. This is divided by 5, so into this, that's equal to 1, which makes it it will be 2 by 9x plus y upon 3 is equal to 1. And the equation of the tangent at 2 minus 5 by 3, this is given by, let's say this is t dash. And this is given by the same thing, it will be there, right? 2 by 9x, now it will be minus y by 3 is equal to 1. So let's say this is equation 1 and this is equation 2. So now, from the first equation, from equation 1, x for the x-intercept, y is equal to 0. For y is equal to 0, you get the value of x as 9/2 and y-intercept x will be 0, which will give you y is equal to 3. Now you have to calculate this area of the, because they are like similar ones. You have to find out, let's say this is 0.0. So you have to find out the area of this shaded portion, AOB. Thus, this x-intercept was your OB and the y-intercept was your OA. This is nothing but OB and this was your OA. Now, area of, first of all, let's find out the triangle AOB. This is given by, half into base into height. Base in this case is OB and height is OA. OB is 9/2. OA is equal to 3. That gives you 27/4 square units. This is the area of the triangle AOB. And in the quadrilateral ABCD, you are having, this is 1, this is 2, 3, and 4. 4 such triangles, similar triangles, concurrent triangles are there. So area of quadrilateral ABCD is 4 times area of triangle AOP. So that is equal to 4 into this. That gives you 27 square units. This is the area of the whole quadrilateral. That makes option A to be the correct answer. Hope you understood this. Next is question number 58. Okay, you are given the coordinates. The P is A sec theta, B tan theta, and Q is this. Are 2 points on this hyperbola. Then 5 plus theta is equal to 5/2 if HK is the point of intersection of the normals drawn at P and Q. Then what is the value for K? Okay, you're given the equation of the hyperbola as this. Now, normal equation at the given point P, A sec theta, B tangent theta, and Q, A sec phi, B tan of phi are AX cos theta, BY cot theta is equal to this, and AX cos phi, BY, BY cot phi is equal to this, where, this is minus theta, and this is the point of intersection of normals drawn at P and Q. So AH into cos theta BK into cot theta is A squared plus B squared. Let's say this is equation 1. Also AH sine theta BK tangent of theta is equal to A square plus B square. This is equation 2. Now let's multiply the first equation by sine theta and second one by the cos theta, and then after that subtraction. Okay, and then subtraction. First of all, let's multiply them. So you will have see, this is got to be multiplied by by. Okay, by sine theta and by cos theta. Now it will be bk, on solving this whole thing, bk cos theta minus sine theta will be equal to, so I'm multiplying and subtracting these equations. Okay, so bk cos theta minus sine theta is equal to A square plus B square sine theta minus cos theta, which will make a square plus b square plus bk whole multiplied by sine theta minus cos theta is equal to 0. So that means a square plus b square plus bk is equal to 0 because this is not 0. This is not equal to 0. So that means a squared plus b squared plus bk is equal to 0. That gives you k's value as minus of a squared plus b squared upon b. So this is the value. This is the answer to the question. And you have option D as the answer. Hope you understood this. Next is question number 59. If A is given by this point, B is this, C is this, D is this, then the angle between the lines AB and CD is equal to. Fine, you're given the coordinates. I'm not rewriting these coordinates now, but the direction, because we have to find the angle between the lines AB and CD. So the direction ratios of AB will be given by, so this is A and this is B. So 3 minus 1, that is equal to 2. 4 minus of minus 1 will be 5. Minus 2 minus 2, it will be minus 4. Similarly, the direction ratios for CD will be equal to 3, 2, and 4. Now say, let's say theta be the angle between them. So, cos theta will be given by the dot product divided by their magnitudes, correct? So, this is 6 plus 10 minus 14 whole divided by AB's magnitude will be 2 square 4, 5 square 25 plus 4 square 16. Similarly, 3 square 9 plus 2 square 4 plus 16. So definitely it's 0. See, it's cancelling. Okay. And it's 0 at pi by 2. So theta, that means the angle between them is pi by 2 or 90 degree. Understood? Let's move to the next question, number 60. Consider the following statement. You have an assertion the direction ratios of the line L1 are 257, direction ratios of another line L2 are this. Then the lines N1 and L2 are parallel. All right, the reason says if the direction ratios of a line L1 are this and direction ratios of a line L2 are this, and A1, A2 plus B1, B2 plus C1, C2 is equal to 0, then the lines N1, L2 are parallel. Okay, let's see. Let's pick up the assertion first. Assertion says direction ratios of a line L1 are this and direction ratios of another line L2 are this, then they are parallel to each other. Okay, let's see. This is 2 upon 4. Let's write it like this. 2 upon 4 upon 19. And the second one is 5 upon 10 upon 19. This should be equal to 7 upon 14 upon root 19. Let's see. So if I'm equalizing them, then it will be, see, it is 1 upon 2 all the way. This is 1 upon 2. So definitely the lines all are having the same ratio. Therefore, L1 and L2 are parallel. So that means the assertion is true. Okay. Now let's get to the reason. If the direction ratios of the line L1 are this and the direction ratios of the line L2 are this, then A1 into A2 plus B1 into B2 plus C1 into C2 is equal to 0. Then the lines are parallel. No, then the lines are not parallel. Okay, so that means this reason is wrong. Assertion is true, but the reason is false. That means option C is the correct answer. Hope you understood this. Next is question 61. A line L is parallel to both the planes, this and this. If the line L makes an angle alpha with the positive direction of x-axis, then what is the value for cos alpha? We are given the two planes as 2x plus 3y plus z is equal to 1 and x plus 3y plus 2z is equal to 2. So let's write them. This will be I, J, K and 2, 3, 1. 1, 3, 2. This will be given by I. 6 minus 3, this is 3, minus j. 4 minus 1, that is equal to 3. And plus k, this will be 6 minus 3, which is again equal to 3. So this is equal to 3i minus 3j plus 3k. Let's find out the unit vector of it. This is given by n vector upon the magnitude of it, which is 3i minus 3j plus 3k whole divided by root of 3 square 9 plus 9 plus 9, which is equal to 1 upon this will be 27. So this will be 3 root 3. All right. And here is you have 3i minus 3j plus 3k. So this is equal to 1 upon root 3 I minus 1 upon root 3 j plus 1 upon root 3 k. Since the line L makes an angle of alpha, line L makes an angle of alpha with positive x's, then of course the cos alpha will be equal to 1 by 3, right? So let's check with the options 1 by root 3. Yeah, this is the answer. Hope you got that. Next is question number 62. Limits question, limit x approaching 0, 1 minus x, tan pi by 2x is equal to. Okay, see, as x will approach 1, this whole thing will be turned out to be like tan of pi by 2, that is infinity. So that won't work. What I'll do is I'll say let 1 minus x is equal to t, which makes x is equal to 1 minus t. So now as t is, x is approaching 1, t is approaching 0. As x approaches 1, t approaches 0. So now the limit will be written as t approaching 0, t tangent of pi by 2, 1 minus t. That's equal to limit t approaching 0, t into tangent pi by 2 minus pi t upon 2, which is equal to limit t approaching 0, t cot tan pi by 2, it will be changed into cot. So cot pi t upon 2. That is limit t approaching 0. T upon, I can write it like this, tangent of pi t upon 2. This is equal to 2 upon pi limit t approaching 0, pi by 2 t whole divided by tangent of this, right? That means that's 2 upon pi into 1, because I have multiplied this numerator and denominator by this pi by 2, pi by 2. All right, so this has been taken outside and this has been multiplied in the numerator. So that's it. This is 2 upon pi. This is the answer to the question, and option B is the correct answer. Hope you understood this. Let's move to the next question. Question number 63. If f of 9 is equal to 9 and the derivative of f at 9 is equal to 4, then the whole expression, this whole limit is equal to what? See, if I'm putting x is equal to 9 in this question, then the root of f of 9 minus 3 minus 3 upon root of 9 minus 3. This will be equal to f of 9 is equal to 9, which will be root of 9, 3. So 3 minus 3 upon 3 minus 3, which is 0 upon 0 form. So that means to solve the question, I have to apply the L'Hospital's rule. So for that, if I'm applying the L'Hospital's rule, you will have the limit x approaching 0. Derivative of this is equal to 1 upon 2 root of fx into f dash x minus derivative of 3 is equal to 0 whole divided by this thing. Root of x is having the derivative as 1 upon 2 root x into derivative of x, that is equal to 1. So this is equal to 1 upon at x is equal to 9. When x is approaching 9, this is equal to this into f dash 9 whole divided by 1 upon root of 9. Now this is equal to f of 9 is equal to 9 and f dash 9 is equal to 4. 1 by 9 into 4 upon 1 upon 3. This will be 1 by 9 into 4 divided by 1 by 3. So this will be 4 upon 9 into 3. That will be equal to 4 upon 3. See, I did a mistake over here. This was 1 upon root of 9. So this was supposed to be 3 over here. And now it will be 3. So they will cancel and you will have only 4 as your answer. All right. So this is your answer. Option B is the correct answer. Hope you understood this. Next is question number 64. If secant of log 2 y square is equal to cosec log 2 x square, then what is the value for dy by dx? All right. I can write it like secant log 2 y square is equal to secant, like cosecant will be, if I'm changing the cosecant into secant, so it will be 90 degree minus log 2 x square. Secant, like they will cancel out each other and you will have log to the base 2 y square is equal to 90 minus log to the base 2 x square. This can be written as 2 log 2y is equal to 90 minus 2 log, here was 2x. Now differentiating on both the sides with respect to x, differentiating both sides with respect to x, you will have 2 into 1 by y into 1 upon natural log of 2 dy by dx is equal to minus 1 by 2 into this minus 2 by x into natural log of 2. That gives you dy by dx. 2 and 2 will cancel and you will have dy by dx is equal to minus y upon x, because they will also ultimately cancel. Okay, so that's it. This is the answer to the question and you have option C as your answer. Hope you understood this. Next, question number 65. If e raised to power x is equal to y plus whole this thing, then what is the value for dy by dx? Okay, you are given e raised to power x is equal to this. Now differentiating both the sides with respect to x. With respect to x, you will get e raised to power x is equal to dy by dx plus 2y. First of all, this will be 1 upon this. Okay, into dy by dx. So ex is equal to, I'm taking dy by dx common. This will be 1 plus 2y upon 2 root of y square minus 1. I'm taking the LCM. E raised to power x is equal to dy by dx. This is 2 root y square minus 1 plus 2y whole divided by 2 root y square minus 1. Okay. 2, I'm taking common from the numerator and it will cancel with the denominator. So it will be dy by dx is equal to root y square minus 1 plus y upon root y square minus 1. This is e raised to power x, which is, this gives you e raised to power x dy by dx is equal to See one thing, what was e raised to power x? That was this, y plus y and root of this. So this can be written as e raised to power x is equal to this multiplied, okay, upon root of y square minus 1, which gives me e raised to power x, e raised to power x will cancel, and you will have dy by dx is equal to this value, okay. Now, e raised to power minus x, it will be 1 upon, because this is equal to e raised to power x into minus 1, which will be e raised to power x raised to power minus 1, or 1 upon e raised to power x only. So now it will be 1 upon y plus this expression, which is equal to, let's do this, let's rationalize this. So whole divided by y minus root of this, it will give me y minus root of y square minus 1, a square minus b square. That is it. So y minus root of y square minus 1 upon y square will cancel, and you will have 1. So this is equal to y minus root of y square minus 1. This is e raised to power minus x. Okay. So now e raised to power x minus e raised to power minus x upon 2. If I solve this, you will have this was equal to e raised to power x was equal to this. It is given in the question, y plus root of y square minus 1, and this is equal to y minus root of y square minus 1 whole divided by 2. This is y will cancel, and you will have 2 root y square minus 1 upon 2, which will be equal to root of y square minus 1, right? So you got e raised to power x plus e raised to power minus x upon 2 is equal to root of y square minus 1. Therefore, dy by dx is equal to this, which is nothing but sin hx. Know this formula, right? So that makes option A to be the correct answer. Hope you got that. Let's move to the next question. Question number 66. If x is equal to log of p and y is equal to 1 upon p, let's differentiate this with respect to x, with respect to p. Okay, so you will have dx upon dp is equal to 1 upon p. And you know y is equal to 1 upon p. So this is equal to y. Okay. Also, let's differentiate this. So you will have y dy by dx, or sorry, dp, not dx. Question number 66. If x is equal to log of p and y is equal to 1 by p, let's differentiate both the things with respect to x, differentiating both of them with respect to p. You will have a dx upon dp is equal to 1 upon p. Also, dy upon dp is equal to 1 upon minus 1 upon p square. Okay. You have to find out dy by dx. So let's divide them. dy by dx will be equal to dy by dp upon dx by dp. Correct? So minus 1 upon p square whole divided by 1 upon p. Minus 1 upon p square multiplied by this. So minus 1 upon p. This is the one, right? But minus 1 upon p is not in the options. But we know one thing, x is equal to log p. I'll use that thing. You are given x is equal to log p, which gives you p is equal to e raised to power x. If I use this, then dy by dx will be nothing but minus 1 upon e raised to power x, or this is minus e raised to power minus x. This is the answer to the question. Option A. Hope you understood this. Next is question number 67. It says electric current I is measured by the galvanometer and the current being proportional to the tangent of the angle theta of deflection. If the deflection is read as 45 degree and error of 1% is made in reading it, the percentage error in the current is. Okay, so here approximate error in the current is given by di is equal to f dash I into delta I. So that is a 45 degree angle, which is equal to pi by 4. And there is a 1% error, which is equal to 0.01. So this is equal to pi by 4 into 0.01. Therefore, percentage error in current is given by pi by 4 into 0.01. Now I have to find out the percentage. So I'll multiply it with 100, which will give me pi by 4 as the answer. That makes option D to be the correct answer. Hope you understood that. Next is question number 68. If the equation of the tangent drawn to the curve y is equal to this, where x is lying between -1 and 1 plus pi and x plus 2y is equal to k, then what is the value for k? You are given in the question y is equal to cos of x plus y. Let's differentiate both the sides with respect to x. Both sides with respect to x. You will have a dy by dx is equal to minus sine x plus y into 1 plus. I'm finding out the derivative of 1 plus y. So this will be 1 plus dy by dx. Now, equation of the tangent is given by this. Equation of tangent is x plus 2y is equal to k. Let's say this is equation 2 and let's say this is equation 1. So from here, what is the slope? See, y is equal to minus 1 by 2x plus k. So slope in this case is equal to minus 1 by 2. Which means slope is given by the derivative, dy by dx is equal to 1 by 2. Therefore, minus 1 by 2 is equal to minus sine x plus y into 1 minus 1 by 2. Or minus 1 by 2 is equal to minus 1 by 2 sine x plus y. They will cancel. You will have sine x plus y is equal to 1 or sine x plus 1 is equal to sine pi by 2. That makes x plus y is equal to pi by 2 only. Okay. From here you have y is equal to pi by 2 minus x. Now let's put this in equation 1. I'm using equation 1. This will make pi by 2 minus x is equal to cos of x plus this. Correct? That is equal to pi by 2 minus x is equal to cos of x will cancel pi by 2, which is equal to 0. So that means x is equal to pi by 2. If x is equal to pi by 2, then you will have y is equal to 0. Now I'm using equation 2 to get the value of k. So k was, it was x plus 2y equal to k. So this is pi by 2 plus 0 is equal to k, which means k is equal to pi by 2. That's it. You got your answer. So here it is. Option C is the correct answer. Hope you understood that. Next is question number 69. So assertion reason problem. F is a function. So from the real numbers to the real numbers, a function defined by fx is equal to this e raised to power 1 upon e raised to power x plus 2 into e raised to power minus x. Assertion says f of c is equal to 1 by 3 for some values of c belonging to R. Reason is fx belongs to 0. It lies in the interval of 0 and less than equal to 1 upon 2 root 2 for all the values of x belonging to the real numbers. Then the following options is correct. Okay, let's get back to our question. You are given in the question fx is equal to this. So let's see. This can be written as 1 upon x plus 2 upon e raised to power x, which will be equal to e raised to power x upon e raised to power x into x, which will be e raised to power 2x plus 2. Now, differentiate both sides with respect to x. You will get f dash x is equal to, so it was this, first of all, denominator square and denominator into the derivative of numerator minus numerator into the derivative of denominator. E raised to power 2x into 2. Okay. So this is equal to e raised to power 3x plus 2e raised to power x minus 2e raised to power 3x whole divided by e raised to power 2x plus 2 whole divided whole square. Okay, so this was your f dash x. Okay, for some value of r. Fine. So now if I put this is equal to 0, you will have 2e raised to power x minus e raised to power 3x is equal to 0. I'm taking e raised to power x common. 2 minus e raised to power 2x is equal to 0. That makes either e raised to power x is equal to 0, which is not possible. E raised to power x is not equal to 0. So that means e raised to power 2x, 2 minus e raised to power 2x is equal to 0, which gives you e raised to power 2x is equal to this, or e raised to power x is equal to root of 2, right? Now, for maximum, see, that is why I have put the first derivative equal to 0. For maximum f dash x, it will be equal to root 2 upon 2 plus 2, because it was this. Yeah, for maximum, this is e raised to power x, which is root 2 plus root 2 square plus 2. So this becomes equal to root 2 upon 4 or 1 upon 2 root 2. Thus, for fx belonging to 0 to equal to this for all x belonging to the real numbers. This gives you C belongs to R such that FC is equal to 1 by 3. That makes assertion to be true. So that means our assertion is absolutely true. And the reason is also true, because according to this, the reason is also true. That makes option A to be the correct answer. Hope you got that. Next is question number 60. Now you have to match the following. So it's going to be a bit lengthy question because you have to solve actually 4 questions in one. Okay. So let's go. First of all, you have an integral of sine square x upon cos raised to power 4x into dx. This can be written as integral of tangent square x secant square x dx, which is equal to, see, the derivative of tangent is secant square. So this will be given by tangent cube x upon 3 plus c. So that means this matches with option C. Okay. Now the second one, integral of sine raised to power 4x upon cos raised to power 2x into dx, which is equal to tangent square x. No, it will not be solved like this. Wait, I will not say tangent square x. I'll split this sine square x into sine square x, and 1 sine square x I'm writing down like this. Okay, into dx. So this is equal to tangent square x minus sine square x dx. And tangent square x, so this will be integral of tangent square can be written as a secant square x minus 1. Okay, dx minus and sine square, it can be written as 1 by 2. I'm taking common outside, 1 minus cos 2x dx. So this is equal to integral of secant square x minus dx, 1 dx minus 1 by 2, 1 into dx plus 1 by 2 integral of cos 2x dx. Now it's easy. Integral of secant square is tangent minus tangent x minus x, and this is minus 1 by 2x plus 1 by 2. Cos 2x will have sine 2x divided by 2. So this will be equal to tangent x 1 by 4 sine 2x minus 3 by 2x plus c. Okay, so the D2 part matches with the D option. So this is option 2. Okay, now the next one, sine cube upon cos square. The third, sine cube so this can be written as sine x 1 minus cos square x whole divided by this. So this is integral of sine upon this. So this will be tangent into secant x dx minus cos square. So this is sine x dx, right? So tangent x, secant x, this is the integral. This integral will be secant x plus this will be cos x plus the constant c. And let's see it matches with the option B. Hope you got that. Next is question number 4. Part number 4 actually. This is given by integral of sine cube upon cos cube x. So this is equal to actually tan cube x dx. That is equal to, this can be written as tangent x into tangent square x, which I will write as 1 minus secant square x minus 1. I'll write it properly. Tangent x into tangent square x into dx, which is equal to tangent x into secant square x minus 1 dx. That is equal to tangent x into secant square x minus tangent x dx. Dx will be written everywhere. So no, this one is because tangent's derivative is tan, so this will be tan square x upon 2 minus this will be log of cos x plus c. So this fourth one, it matches with the option A. Okay, so let's check with the options, which is the correct answer out of all these. You will notice that option B is the correct answer. Hope you understood that. Next is question number 1. It says if integral of this, let's write it in simultaneously, integral of x upon a plus x raised to power 5 dx is equal to 1 upon k into a plus x raised to power 4 fx plus c. Then what is the value of f of minus a divided by ak? See, I'll take the LHS first. So let's say this is equal to some I. So I will write it like I is equal to a plus x minus a whole divided by a plus x raised to power 5, which can be written as a plus x whole divided by a plus x raised to power 5 minus a upon a plus x raised to power 5 dx, right? Now this is equal to 1 upon integral of a plus x raised to power 4 dx minus of this, I'm writing as such. So this is equal to minus 1 by 3, 1 upon a plus x raised to power 3 plus a is a constant, it will be taken outside, a by 4 into 1 upon a plus x raised to power 4 plus c. Okay, it's a bit tilted. So, okay, this was 1. I'm taking a plus x raised to power 4 as the LCM minus 1 by 3. Okay, 12. Let's take this 12 over here. So this will be equal to minus 4a plus x plus 3a plus the constant c. So this will be minus 4a, 4x, 3a whole divided by 12 into this. So this will be minus 4x minus a upon 12 into a plus x whole raised to power 4 plus c. So that makes this is equal to f of minus a upon ak. Let's compare it. This is equal to f of minus a upon ak. I have to compare it. See, if I'm using this one, let's continue with the integral. This was minus 4x minus a whole divided by 12 into a plus x raised to power 4 upon c. If I'm comparing it with f of minus a upon a into k. So f of minus a, that makes fx is equal to minus this. And of course, if this is the one, then k's value will be equal to 12. Okay, if I'm comparing, see, f of minus a upon ak, this will be 4a plus minus a upon a, this was a into 12. That gives you question number 71. If integral of, let's write it simultaneously, x upon a plus x raised to power 5 dx is equal to 1 upon k into this into f of x plus c, then you have to find out the value of this expression. Let's take the LHS. Let's say this is equal to I. So what I'll do is I'll add and subtract an a from here. Okay, now this will be equal to a plus x upon a plus x raised to power 5 minus integral of a plus x raised to power 5 dx. This is equal to integral of 1 upon a plus x raised to power 4 dx minus, I'm taking the a outside. So a into, if I'm finding out the integral of this, let's write it down first. So this is equal to 1 upon a plus x raised to power minus 4 plus 1, which is equal to minus 3. If I take in the denominator, it will be 3. And it will be multiplied by minus 1 by 3. Minus a, similar thing, minus 1 by 4 into 1 upon a plus x raised to power 4 plus the constant c. So that is equal to minus 1 upon 3, this minus plus a upon 4, a plus x raised to power 4 plus c. So you have a plus, I'm taking the LCM, 12a plus 4 raised to power x. That's got to be minus 4a plus x plus this will be 3a plus c, and keeping it separate. So this will be, when opened, it will be minus 4x minus a upon 2 a plus x raised to power 4. Now let's compare it with the given equation, which was 1 upon k into a plus x raised to power 4 fx plus c. So from here you clearly see that fx is equal to minus 4x minus a and k is equal to 12. And what you have to find out is, to find is f of minus a upon a into k. So f of this, that makes minus 4 into minus a upon a is, let it be a only, and k is this. So that makes 4a minus a, which is equal to 3a upon 12. That makes the answer to the question as 1 by 4. So option D is the correct answer. Hope you understood that. Let's move to the next question, number 72. Again, an integral problem. So this is the one. I'm starting it from here only. So this is integral secant x. I'm doing what? dividing the numerator, multiplying the numerator and the denominator by multiplying numerator and denominator by cos square x. So the integral now will be secant will be changed into cos x dx whole divided by cos square x 1 plus 2 sine square x. Okay. Okay, fine. So now what should be done next? Let's do one thing. Integral of, I forgot to put the limit 0 to pi by 4, 0 to pi by 4 cos x. I'm changing this into 1 minus sine square x, 1 plus 2 sine square x dx. Now let's put sin x as t. So its derivative cos x dx will be equal to dt. Also, the limits will change like when x is approaching 0, t will approach 0 and x will approach pi by 2, t will approach 1 by root 2. Okay, so now this will be changed to integral of 0 to 1 upon root 2 dt upon 1 minus t square 1 plus 2 t square. Okay, so now this can be written as integral 0 to 1 by 2, the roots limits. That's equal to a upon 1 minus t, b upon this ct plus t 1 plus 2t square dt. Okay, so that's equal to integral 1 to limits 1 to 2 root 2. This will be, see, let's solve that separately. When you will solve that separately, that's going to be quite a task. So on separately solving that, you will get the values of a, b, and c. You will solve it to get the value of a will come out to be 1 by 6, b will come out to be again 1 by 6, and c will be 0, and d will be 2 upon 3. Okay, so now I'm putting that over here. So a is equal to 1 by 6 into this dt plus 1 by 6 again, 1 plus t dt plus 2 by 3 ct. So integral of dt upon 1 plus 2t square. Okay, so now this is whole thing is equal to integral 1 limits 0 to 1 by root 2. I'm taking 1 by 6. I'm finding the actually this integral only now. So this will be equal to 1 by 6 will be taken outside, log of 1 minus t limits this plus 1 by 6 log of this. These are the limits plus 2 by 3 into 1 by 2 into 1 by root 2 tangent inverse root 2 t. Okay, the limits again this. So now I'm putting the limits. This will be equal to this will be minus 1 by 6. Yes, because it is the denominator, right? So it will be this. So now this will be minus 1 by 6 natural log 1 minus 1 upon root 2, 1 minus 1 upon root 2, 1 minus this plus 1 by 2 log 1 plus this plus 1 upon 3 root 2 tangent inverse 1. That's equal to 1 by 3 log of root 2 plus 1 plus 1 by 3 root 2 into pi by 4. See, I have a, into pi by 4. This is log root 2 plus 1 plus pi root 2 upon 12. So this is the answer to the question. Let's check with the options. You have first option, A, as your answer. Hope you got that. Let's move to the next question, number 73. Before starting with the question, students, here's a quick reminder to visit our website, www.examsnet.com. This site is a great place for you to practice your entrance exam question papers and similar type of many more entrance exam question papers. You must download our app for the better preparation. The link is available in the description box. So let's start with the next one, question number 73. Here you have integral of x raised to power 4 log x raised to power 3 dx is equal to x raised to power 5, this whole expression plus k. Then what is the value of a plus b plus c plus 5t? Let's pick up your LHS. You have x raised to power 4 log x raised to power 3 dx, which is equal to log x first function into the integral of second minus integral of derivative of the first. So it will be 3 log x square into this dx. So that's equal to x raised to power 5 upon 5 log x whole cube minus 3 by 5 integral of x raised to power 4 log x whole square dx. So this is equal to x raised to power 5 upon 5 log x whole raised to power 3 minus 3 by 5 log x square into this minus 2 into log x 1 by x into this. So this is equal to x raised to power 5 upon this into this minus 3 by 5. Now it will be 3 by 25. Okay, log x raised to power 5, 6 upon 25, integral of x raised to power 4 log x dx. This is log x cube minus 3 upon 25 log x square into x raised to power 4 plus 6 by 25. This whole will be multiplied by into log of x minus integral of this into this. That's x raised to power 5 log x cube minus 3 by 25 log x whole square into x raised to power 5 plus 6 upon 125 minus 6 upon 625. Into x raised to power 5 upon 5. I think I've written everything. Let's check once again. X raised to power 5, this. 6 upon this log x. Yeah, I forgot to write x raised to power 5 over here. And minus 6 upon this into x raised to power 5 plus the constant k. Now I'll take the x raised to power 5 common from all the terms. So this will be x raised to power 5. I'll be left with 1 by 5 log x cube minus 3 upon 25 log x square log x it was 125. Yeah. Plus the constant c. Okay. Or the constant k, whatever you want to say. So let's compare it with the given one. So this is it. This was the given one. So from here, A, B, C, and D. Let's write down their values. I'm comparing it with the given equation. Comparing with the given equation. You have A as 1 by 5, B as 3 by 25, minus C this, and D this. Right. Now let's get back. What we needed to find out was the A plus B plus C plus 5D. To find so 1 by 5 minus 3 by 25 plus 1 upon this minus, I'm multiplying it with 5, so I'll have minus 6 upon 125. So first of all, they will cancel out, and you will have 25 will be the LCM, 5 minus 3. So you have 2 upon 25 as the answer. Let's check with the options. Option A. Hope you understood this. Next is question number 74. Now limits question. Let's write on the question. N approaching infinity, 1 upon n square, secant square, 1 by n square, 2 upon n square, secant square, 4 upon n square, till 1 upon n secant square 1. Okay. So now let's do one thing. Limit n approaching infinity. Okay. So is a correction. This is n square, and let's take 1 by n square common. So you will have secant square 1 by n square, 2 secant square 4 by n square, so on till 1 by question number 74. If limit of this whole expression, okay, fine, you have to find out the value of this whole expression. Let's write it down. Limit n approaching infinity, 1 upon n square, secant square 1 by n square, plus 2 upon n square, secant square 4 by n square, so on till 1 by n. I can write it like this, n square upon, n upon n square, right? That will be equal to 1 by n only. Secant square 1. So secant square 1 can be written upon n square upon n square. I have done these two changes. First of all, 1 by n, I have transformed into n upon n square. And secant square 1, I have changed that into secant square n square upon n square. That has a reason for it. Let's see. See, now this limit will be equal to limit n approaching infinity. 1 by n square, I have taken common from all of them. So I have secant square 1 by n square plus 2 secant square 4 by n square, so on till n upon n square, n square I have taken already common. So here will be n, into secant square n square upon n square. This is nothing but limit n approaching infinity, summation from r is equal to 1 till r is equal to n. This r upon n square into secant square r upon n whole square, right? So that's limit n approaching infinity, summation r from r is equal to 1 till n, 1 by n r upon n secant square r upon n whole square, which is integral of limit 0 to 1 x secant square x square dx, which is nothing but, wait a minute. This is nothing but the derivative of tangent of x. Okay. So you have a tangent of x, limits 0 to 1. And 1 by 2 also will be introduced because this is a power of 2. So that's it. This is it. You have this is half of tangent of 1 minus tangent of 0, which is half of tangent of 1. So this is the answer to the question. Let's check. You have half of tangent of 1, option D as the answer. Hope you got that. Let's move to the next question, number 75. Integral of 2 to 5, this whole thing is equal to, okay, let's write it down. 2 to 5 integral 5 minus x upon x minus 2 dx is equal to, let's say, let's put x square, x minus 2 is equal to z square. I'm finding the derivative, so dx will be equal to 2z into dz. Now, as x is approaching 2, this will be, z will be 0, and when x will be approaching 5, z will be equal to 3. So now the limits will change from 0 to 3. Sorry, it will be z square will be 3, so z will be equal to root 3. Okay. Now limits have changed, and this will be root of 5 minus z square plus 2 upon z into 2z dz. Z and z will cancel. So 0 to root 3. This will be 3 minus z square. Under the root, z have cancelled, and I'm taking this 2 outside into dz. Okay. Now let's find out the derivative. Integral, sorry. So 2 is taken outside. This will be z into root 3 minus z square upon 2. This is question number 75. You have to find out this integral. Let's write it down. Limits 2 to 5, root of 5 minus x upon x minus 2 into dx. All right. Let's say x minus 2 is equal to z square. So you will have the dx is equal to 2z into dz. So now this limit, also one more thing, when x is approaching 2, the z will approach 0, right? And when x is approaching 5, z will approach root of 3, because z square will be equal to 3, so z will be equal to, z will approach root 3. So limit 0 to root 3, this will be the 1, and now it will be changed into root of 5 minus z square plus 2 whole under the root into 2z dz whole divided by z. First of all, the z and z will cancel, and then you will have, this will be equal to this thing 2 I'm writing outside. So root of 5 minus 2, which is equal to 3 minus z square. Let's write it properly once. So this is it. That's equal to 2, 0, root 3, root of 3 minus z square. Dz, you know, the integral for this is 2 into 3, which is, this is a square, right? So 3 by 2 sine, not sine now, this will be root of 3 minus z square plus 3 by 2 sine inverse z upon root 3, limits 0 to root 3. Let's put the limits. So you will have 3 by 2 sine inverse 1 minus 3 sine inverse 1. This is equal to 3 pi by 2. So this is the answer to the question. Option C is the correct answer. Hope you understood that. Next is question number 76. Let's go to that. Hope you're getting all the questions. So next is question number 76. It says, again, an integral problem. I'm going to write it 0 to pi by 2, the limits, sine 6x cos raised to power 4 x dx. I'm going to use Wallis formula over here. So integral 0 to pi by 2 sine mx cos nx dx, where m and n are integers, is given by m minus 1 into m minus 3, so on till 2, or n minus 1, n minus 3, so on, 2 or 1. Whole thing divided by m plus n into m plus n minus 2, so on till 2 or 1. Okay. So here lambda is equal to pi by 2, and m and n are both even. So let's say this let's say this is equal to 0 to pi by 2 sine 6 cos 4 dx. This will be equal to 5 into 3, 1, 3 into 1, whole divided by m plus n, that's 10, 8, 6, 4, 2 into this. I hope I've written lambda over here. I forgot. Into lambda. Okay. So this becomes like the cancellations and everything. So you will cancel this at 2. And ultimately, when you will solve it, this will also cancel at 2. So you will get it as 3 pi upon 512. So this is the answer to the question. 3 pi upon 512. Option C is the correct answer. Hope you understood that. Next is question number 77. The area in square units bounded by this curve and this line is. This is a pretty easy question. Let's go. First of all, let's make the figure to understand the problem better. So here's your coordinate axis. Let's draw this. The given curve is y is equal to 2x minus x squared. It's passing through the origin, of course. So it is something like this. The curve is somewhat like this. Okay. And this is the line, y is equal to minus x. Y is equal to minus x is, of course, this line. It is again passing through the origin. So this line, basically what you have to find out is the area of this shaded region. Correct? First of all, what is the point of intersection of this curve with the x-axis? We'll find out it is 2, 0. See, when I'm putting x is equal to 0, when I'm putting y is equal to 0, x will come out to be 2. Right? And this is, of course, your origin, the coordinates 0 and 0. This is your curve. Y is equal to 2x minus x squared. And also, what if you will find out the point of intersection for this curve and this line? This will be minus x is equal to 2x minus x squared. Or you will have x squared is equal to 3x, which will give you the two values. Right, that means x. So x will be 0 or x will be 3. So when x is equal to 3, you will find out the value of y will be equal to minus 3, and here y will be 0. Therefore, this is the first point of intersection of the curve with the line, and this is the second point of intersection of the curve with the line. Hope you understood till here. Now, required area is given by from 0 to 3, 2x minus x square minus of minus x dx. Correct? This is 0 to 3, 2x minus x square plus x dx, 0 to 3, 3x minus x square dx. Now I'm finding out the integral of it. This will be 3x square upon 2 minus x cube upon 3. Limit 0 to 3, which is equal to 27 upon 2 minus 27 upon 3. Minus 0. Now I'm taking the LCM. 681 minus 54, which is 27 upon 6 or 9 upon 2. So this is the answer to the question. 9 upon 2. Option A is the correct answer to the question. Hope you got that. Let's move to we are approaching towards the final questions of this paper. Actually, some were pretty tough and some are on the lighter side. So let's go with question number 78 now. The degree and the order of the differential equation of the family of the parabolas whose axis is x-axis are respectively. Now you're talking about the family of the parabola whose axis is the x-axis. That means you are having the parabola of the form this, right? Is alpha, where a and alpha are the constants. Now let's differentiate both the sides with respect to x. Both sides with respect to x. You will get here 2y dy by dx is equal to 4a, or y dy by dx is equal to 2a. I'm differentiating it again. So y into d square y upon dx square plus dy upon dx square. This is equal to 0. So you have to find out the order and the degree. So what is the degree over here? First of all, what is the order of here? That is 2. And what is the degree of it? 1. Right? Which makes option C to be the correct answer. Hope you understood this. Pretty easy one. Next is question number 79. The general solution of the differential equation. This is equal to this is. Okay. Let's write down the equations. You have x sine y upon x dy is equal to y sine y upon x minus x dx. Let's write down dy by dx. That's y sine y by x minus x upon x sine y by x. Let's say y is equal to vx. So this gives you dy by dx is equal to v plus x into dv by dx. Okay. So v plus x into dv by dx. This is vx into sine v minus x sine v. Now, how did I get this is, I'm using this equation. Here y is equal to vx. So y vx and y by x is equal to v. So I have just used this to fill in this. Okay. So I get 2 over here. Now it will be v plus x into dv by dx is equal to, I'm taking the x common and cancelling it. You will be left with v into sine v minus 1 upon sine v, or x dv by dx will be equal to v sine v minus 1 upon sine v minus v. So x dv by dx is equal to sine v sine v minus 1 minus this. These 2 will cancel and you have minus 1 upon sine v. Okay. So you can say sine v into dv is equal to minus 1 by x into dx. Correct? Till here. Let's integrate on both the sides. So sine's integral is minus cos v, and this is minus log of x and plus c or minus c, like whatever you want to say. Plus c. And let's put v. V was equal to y by x. Okay. And this is equal to minus log of x plus c. I'm cancelling minus on both the sides. Cos this is equal to log this. I'm again keeping it as positive or negative. It doesn't matter because it's a constant, like it can have any value. Okay, hope you understood this thing. So now that makes option D to be the correct answer. Hope you understood that. Let's move to the last question of the paper, question number 80. A very best of luck. This is going to be the last one. Mathematical question. The general solution of the differential equation this. Okay, let's read it. Let's write it down as well. 2x minus 10y cube dy plus y dx is equal to 0. Let's rewrite it. It will be 2x minus 10 y raised to power 3 dy is equal to minus y into dx. Correct? So you have a dx upon dy is equal to minus 2x. Yeah, it will be minus 2x upon y plus 10y square. Or you have dx upon dy plus 2x upon y is equal to 10y square. Here the integrating factor is equal to e raised to power 2 upon y dy, which is equal to e raised to power 2 log y. This is equal to y square. So the solution is x into y square is equal to integral of 10y square into y square into dy plus c, which is 10 into y raised to power 4 dy plus c, or 10 into y raised to power 5 upon 5 plus c, which is this. Okay, that was your x into y square. So x y square minus 2y raised to power 5 is equal to c. This is it. You have option B as your answer. So students, with that, we have completed all the 80 mathematical questions of this paper. Hope you understood them well. And don't forget to visit our website, www.examsnet.com. This site, as you know, is a great place for you to practice for your many more similar type of entrance exams and this as well. You will get lots of similar type of question papers for your practice. For a better study, you must download our app. The link is available in the description box. So, a very best of luck. Keep shining, keep rising high. That's all for this paper. Bye.